3 years ago, on a cold December morning in 2021, humanity paused in collective anticipation. A gleaming rocket rose from French Guiana, carrying not just metal and machinery, but 3 decades of persistence, $10 billion in resources, and the sleepless determination of thousands of scientists and engineers. This was no ordinary launch. It was the birth of a dream. The James Webb Space Telescope had finally begun its voyage, a mission designed to transform how we perceive the universe itself. Imagine the weight of that moment, the culmination of decades of ambition balanced on a single fiery ascent into the dark. For many, it felt like witnessing the opening of a new chapter in human history. This machine was not built simply to replace the Hubble or to snap prettier pictures. It was built to peel back the veil of time itself, to gaze into an era when the cosmos was still young and raw, glowing with the faint afterlight of creation. We are talking about a time window stretching over 13 billion years into the past, an era before galaxies matured, before stars like our Sun even existed. What launched that December morning was not just a telescope, but humanity's first true time machine. And here is why its story matters. From its perch nearly 1 million miles away, this observatory has begun rewriting everything we thought we knew about space, about creation, and even about our place within it. The data flowing back is more than scientific records. It's a reshaping of perspective, a reminder that we are participants in a vast and evolving story that stretches far beyond our small blue planet. What makes this adventure truly compelling is where Webb actually operates. Unlike Hubble, which circles Earth, this telescope was sent to a peculiar point in space, a place known as Lagrange Point 2. At that location, the gravitational balance between Earth and the Sun creates a stable orbital sweet spot. Imagine a cosmic parking space, perfectly balanced, where Webb can remain in darkness, hidden behind a massive sunshield about the size of a tennis court. That thin barrier is stronger than any sunscreen imaginable, blocking the star's heat with protection equivalent to SPF 1 million. Behind it, Webb's instruments cool to frigid temperatures colder than the icy surface of Pluto. This isn't designed for design's sake, it's survival. Why such extreme measures? Because the universe itself is stretching. Light, traveling through billions of years, gets stretched along with it. So ancient starlight that once shone in visible colors has now been elongated into invisible infrared radiation. To human eyes, these signals are lost. But Webb is different. Its sensors are crafted to catch that ancient glow, the whispers of the first stars and galaxies. Every time it observes the deep sky, it's peering backwards into cosmic history, unearthing secrets older than the Earth itself. Think of it as an archaeologist carefully uncovering layer after layer of time, except instead of stone tools or fossils, it reveals galaxies, stars, and the very fingerprints of creation. But even the most optimistic scientists weren't prepared for what the telescope actually found once it started operations in mid-2022. Within mere months, the images and measurements sent back began shaking long-held assumptions, sparking both excitement and confusion across the scientific community. The surprises didn't take decades to appear. They arrived almost immediately. One of the most jaw-dropping revelations emerged in May 2024. Webb spotted a galaxy so early in the cosmic timeline that it shouldn't exist, at least not according to our established models. This galaxy, known as JDS-GSC 13-0, was shining just 290 million years after the Big Bang. Put that into perspective. If the universe's entire 13.8 billion-year history were condensed into a single year, this galaxy would have already formed by the first week of January. That's astonishingly early. The discovery was more than a milestone. It was a direct challenge to our theories of how quickly matter can organize into complex systems. According to our best models, galaxies that large and luminous should have taken far longer to form. Yet here it was, glowing defiantly in Webb's gaze. One scientist, Peter Van Dokkum of Yale, described it with awe, calling it the most distant object ever identified, and pointing out that no one expected such a structure to emerge so soon after the universe's beginning. This wasn't supposed to be possible, not this fast. The implications are staggering. If entire galaxies could form in such a short time, it means the early universe wasn't a slow, meandering process of gradual assembly. It was dynamic, efficient, and wildly creative, building order and complexity at a pace that defies our expectations. It's as though you learned that ancient civilizations were constructing enormous, sophisticated cities almost instantly, long before anyone believed humans capable of such feats. And this galaxy was not an outlier. Webb has already uncovered multiple massive galaxies from that same young era, some with sizes comparable to the Milky Way itself, appearing less than 1 billion years after the Big Bang. Each one raises new questions. How did matter collect so quickly? How could gravity sculpt structures so large in such little time? Our textbooks can't fully answer yet, and that's what makes the discovery so exciting. Digging deeper, Webb's instruments revealed another surprise. The chemistry of these early galaxies doesn't match what we see in the stars nearby, in our own corner of the cosmos. By splitting starlight into its component colors, Webb can identify which elements are present, and what it found is strange. These ancient galaxies contained unexpectedly high amounts of nitrogen, while other heavier elements appeared in far smaller quantities than predicted. This suggests that the early stars were living and dying under conditions very different from those we know today, forging elements in ways we don't yet understand. It's like stumbling across ancient smiths who managed to create alloys unknown to modern metallurgy, compositions that by all logic should be impossible. This shakes the foundations of stellar evolution theory. For decades, we believed we had a fairly complete picture of how stars burn, collapse, and scatter their enriched material back into the cosmos. Webb has shown us that picture is incomplete. There are missing pieces in the puzzle of how galaxies, planets, and eventually life itself emerged. And there's more. The very shapes of these primordial galaxies defy expectations. Instead of resembling the familiar spirals or ellipticals we observe in nearby space, Webb has revealed disks, ovals, and even elongated tube-like structures. They don't fit neatly into the categories astronomers have relied on for decades. Once again, it's as if you unearthed ancient buildings constructed with entirely different architectural principles, designs both practical and beautiful, yet governed by rules we are only beginning to grasp. The surprises didn't stop with vibrant, fast-growing galaxies. Webb also uncovered something far less expected: entire systems that had already gone dark. These cosmic husks are galaxies that blazed brilliantly in their youth, exhausting their fuel in furious bursts of star birth before fading into silence. Hubble and ground-based telescopes had hinted at their existence, but only Webb's razor-sharp instruments could dissect their faint light with enough detail to tell us when they lived, how quickly they aged, and exactly when they fell dormant. It's as if astronomers suddenly gained access to a forensic laboratory capable of not only confirming a death, but also reconstructing the precise circumstances surrounding it. The ability to study these silent galaxies is more than a scientific curiosity. It provides a timeline of cosmic life and death cycles. Each dormant galaxy is a clue, showing us how rapidly matter can ignite, burn, and then collapse into stillness. For the first time, astronomers can map these phases with accuracy rather than speculation. One researcher put it plainly before Webb: the early universe was mostly a mystery built from theory and computer models. Now we have direct observational evidence that bridges the gulf between the explosive birth of the cosmos and the rich landscape of galaxies we see today. And these discoveries are stirring some of the biggest debates in modern astrophysics. Scientists are asking whether our existing models of the universe can be stretched to fit Webb's results, or whether something more radical is required, a fundamental rethinking of cosmic evolution itself. Is it possible that the first generations of stars formed far more efficiently than we imagined? Could dark matter, the invisible framework holding galaxies together, behave in ways we don't yet understand? The scientific community is divided, but what's clear is that our neat step-by-step timeline of the universe's growth no longer holds. Webb has upended it. The implications extend far beyond academic circles. These revelations are rewriting our own origin story, reshaping how we understand the transformation from a hot, dense, simple beginning to the intricate universe surrounding us today. To study those early times isn't just to satisfy curiosity, it's to grasp the fundamental processes that govern how structure arises from chaos, how raw gas becomes stars, how stars scatter the ingredients for planets, and how eventually life itself emerges. Each Webb discovery is a reminder that the laws of nature we rely on may have operated differently when the cosmos was young. Standing here in the early years of Webb's mission feels like witnessing a turning point as profound as Edwin Hubble's realization that the universe is expanding. The telescope's observations reveal a universe that assembled faster, more creatively, and more efficiently than anyone dared to imagine. Yet, as staggering as these revelations are, they represent only a fraction of what Webb can do. Its capabilities stretch beyond ancient galaxies and cosmic dawn, reaching into the territory of stars and planets much closer to home, objects that may hold the very keys to life itself. As Webb's gaze shifted from the earliest galaxies to our galactic neighborhood, its versatility became clear. This is not just a machine for probing the first billion years of existence. It is equally capable of scrutinizing planetary systems orbiting stars just a short distance away on the cosmic scale. Among these systems is one of the most tantalizing finds in modern astronomy, a compact arrangement of 7 rocky planets circling a small red star just 40 light-years away. This star system, known as TRAPPIST-1, has fascinated astronomers since its discovery in 2017, not only because of the number of Earth-sized worlds it contains, but because several of them orbit within a zone where liquid water could potentially exist. Picture the scene: if you stood on the surface of one TRAPPIST-1 planet, the others would loom in the sky larger and brighter than our moon does from Earth. It's a view that almost feels like science fiction, but it's very real. Red dwarf stars like TRAPPIST-1 are the most common type of star in our galaxy, meaning that if their planets can hold on to atmospheres and sustain water, the number of habitable worlds in the Milky Way might be far greater than we ever dared to believe. But there's a catch. Red dwarfs may live long, stable lives, but their youth is turbulent. In their early stages, they unleash storms of radiation and violent flares, eruptions powerful enough to strip entire atmospheres from surrounding planets. For years, scientists wondered whether the TRAPPIST-1 system was doomed by its star's volatility. Were those 7 worlds just scorched, airless rocks? Or could some have endured, retaining the fragile envelopes of gas that make liquid water, and maybe life possible? This is where Webb once again proved its worth. Using its mid-infrared instruments, the telescope achieved something unprecedented. It captured direct thermal emission from a planet almost identical in size to Earth. For the first time, astronomers could measure the faint glow of heat radiating from a rocky exoplanet. That single observation answered questions that had lingered for years, and opened the door to entirely new ways of studying alien worlds. What Webb achieved next marked a milestone that only a decade ago seemed unthinkable. Astronomers directed its instruments toward TRAPPIST-1b, the innermost planet in that tightly packed system. By measuring the faint heat escaping from its surface in the infrared, they determined that its dayside bakes at nearly 500 Kelvin, around 450 degrees Fahrenheit. But the temperature wasn't the most sobering revelation. What truly mattered was what wasn't there: an atmosphere. The searing radiation from its red dwarf star appears to have stripped away any protective gases long ago, leaving nothing but a bare rocky husk orbiting dangerously close to its fiery host. It's a reminder of just how fragile the conditions for life really are, and how easily entire worlds can be rendered sterile. But Webb's work didn't end with that first disappointment. The telescope next turned its attention outward to TRAPPIST-1d, a planet orbiting farther from its star, in a zone where liquid water might be possible. This world quickly became a prime candidate for atmospheric studies, raising hopes that it might be one of the rare Earth-like havens beyond our solar system. Yet when Webb's spectroscopic data was analyzed, the results were sobering once again. The signature of an Earth-like atmosphere was absent. Caroline Play-Goring of the University of Chicago summed it up succinctly: "These observations let us cross TRAPPIST-1d off the list of possible Earth twins." And yet, in science, every door that closes seems to open 2 more. A reanalysis of TRAPPIST-1b has already begun to complicate the original picture. Looking with different instruments and wavelengths, astronomers now believe the innermost planet might actually possess a thin, hazy blanket of carbon dioxide, or alternatively, its extreme surface heat could be evidence of ongoing volcanic activity, powerful enough to resupply gases even as the star's radiation tears them away. In other words, this small rocky world might not be a lifeless rock after all, but a geologically restless planet still shaping its destiny. This duality captures the essence of Webb's power. It's not limited to a single technique. It can observe the same planet through multiple methods, each revealing a different layer of truth. One approach measures heat, another identifies gases, while still others pick out chemical fingerprints invisible to human eyes. Together they weave a fuller picture, like having several specialized microscopes each designed to reveal hidden details the others cannot. The stakes of these discoveries extend far beyond one planetary system. By learning whether atmospheres can survive around red dwarf stars, astronomers are building a roadmap for habitability across the galaxy. Since red dwarfs are by far the most common stars in the Milky Way, this knowledge will help determine whether Earth-like environments are rare exceptions or widespread opportunities for life. Every TRAPPIST observation refines the odds of how many habitable worlds might exist among the hundreds of billions of stars scattered across our galaxy. But Webb's mission has never been about exoplanets alone. Its infrared vision has also been trained on the most extreme objects known, supermassive black holes. These titans sit at the centers of galaxies, sculpting their surroundings with gravitational power that defies comprehension. What Webb has revealed about them is rewriting one of the most perplexing chapters in cosmic history. In the constellation Telescopium, Webb detected what looked at first like a small red dot, faint and unremarkable. Yet, appearances can deceive. That compact source, seen as it was only 500 million years after the Big Bang, harbors one of the earliest black holes ever discovered. The giant at its center, anchoring the galaxy Sears 1019, tips the scales at roughly 38 million times the mass of our Sun. For comparison, that's about 10 times more massive than the behemoth that sits in the heart of our Milky Way. The shock isn't simply its size, but its proportion. This black hole accounts for nearly 5% of the total stellar mass of its host galaxy. To grasp the magnitude of that imbalance, consider that in today's universe, central black holes typically amount to just 0.1% of their galaxy's stars. Stephen Finkelstein, one of the astronomers behind the discovery, noted that this is more than an oddity. It's evidence that early black holes either formed far larger than our models allow, or grew at breakneck speeds that seem to defy physics as we understand it. And Webb kept piling on surprises. In May 2024, it captured evidence of the most distant black hole merger ever seen. Two enormous black holes were spotted mid-collision inside a galaxy system designated ZS7, only 740 million years after the Big Bang. This wasn't just a new record, it was the first time such a cataclysm had been observed at such an early stage in cosmic history. The energy unleashed in black hole mergers dwarfs anything else in the universe, radiating gravitational waves with power that exceeds the combined light of every star in the observable cosmos. The fact that events of this scale were already taking place less than a billion years after creation suggests that supermassive black holes achieved their enormous size through violent collisions as much as through steady growth. Perhaps most provocative of all is evidence that not every early black hole was born the same way. In data from the Cosmos Webb survey, astronomers identified an odd structure dubbed the Infinity Galaxy. Two compact red nuclei are surrounded by luminous rings, resembling the sideways figure 8 of the infinity symbol. The object appears to be the aftermath of two galaxies colliding head-on, and between those twin cores lies something even stranger, a supermassive black hole that may not have grown from smaller stellar remnants at all, but instead formed directly through the collapse of a colossal gas cloud. If confirmed, this represents a kind of cosmic shortcut, skipping the slow incremental growth we once assumed, and instead producing a monster black hole millions of solar masses heavy from the very beginning. It's the astrophysical equivalent of discovering that some mountains didn't rise gradually over eons, but instead appeared fully formed as if dropped whole from the sky. These direct collapse scenarios could explain how black holes in the early universe became so huge, so fast, rewriting once again what we thought possible. Perhaps the most astonishing revelation yet came when Webb observed a black hole breaking the very rules of physics as we know them. Using combined data from both Webb and NASA's Chandra X-ray Observatory, astronomers identified a relatively low-mass supermassive black hole, seen as it existed just 1.5 billion years after the Big Bang. What set this object apart was its feeding frenzy. It was devouring material at a rate more than 40 times higher than what theory says should even be possible. In astrophysics, there's a concept known as the Eddington limit, a threshold that marks how fast a black hole can consume matter before the outward push of radiation forces incoming material away. Yet this object was blasting past that supposed barrier, a phenomenon called super-Eddington accretion. It's the cosmic equivalent of a drain swallowing water faster than it can be poured in, a process that by every model of physics should be impossible. Haiwei Zhang of the International Gemini Observatory, who led the study, explained that this may hold the key to one of astronomy's great puzzles, how supermassive black holes in the early universe became so enormous in such a short time. If even brief episodes of runaway feeding can cause massive growth spurts, then the origin of these monsters might not require slow, steady accumulation across billions of years. Instead, black holes could bulk up dramatically in short-lived bursts, regardless of whether they began life as small light seeds or already massive heavy seeds. These discoveries underscore a deeper truth, that black holes are not just exotic curiosities. They are central characters in the cosmic story, shaping the galaxies around them, and influencing the very architecture of the universe. Webb is showing us that this relationship between galaxies and their central giants was established astonishingly early. From the beginning, black holes and galaxies seem to have grown together, intertwined in a cosmic dance that sculpted the universe we see today. The early cosmos was not the calm, orderly place we once imagined. It was restless, turbulent, and astonishingly efficient at building massive structures in record time. And the surprises did not end with black holes. Webb's versatility allows it to shift focus from the most massive structures in existence to some of the smallest, most elusive objects ever found, brown dwarfs. For decades, astronomers have catalogued these strange bodies within the Milky Way. They exist in the gray zone between planets and stars, too heavy to be planets, yet too light to ignite the nuclear fusion that defines true stars. Until recently, they had only ever been found close to home. Then Webb pushed the boundary further than ever before. In the star cluster, NGC 602, located outside the Milky Way, it detected the first substantial population of brown dwarf candidates beyond our galaxy. Elena Manjavakis of the Space Telescope Science Institute described the discovery as groundbreaking. Until now, every one of the roughly 3,000 known brown dwarfs was found within our galactic neighborhood. Finding them in another galaxy is like unearthing artifacts from an ancient civilization on a completely new continent, revealing how stellar systems may have formed under very different cosmic conditions. But Webb went further still. It found the new record holder for the tiniest free-floating brown dwarf ever detected, an object only 3 to 4 times the mass of Jupiter, wandering alone through interstellar space without a parent star. Kevin Lufan of Penn State University, who led the study, pointed out that this tackles one of the oldest questions in astronomy: what is the smallest possible star? Webb is now giving us answers by uncovering objects right on the razor's edge between planets and stars. These faint, fragile worlds blur the boundaries of how we classify cosmic bodies. They form like stars, through the collapse of gas clouds, yet are small enough to resemble oversized planets. Even more surprising, Webb has confirmed that some brown dwarfs host swirling protoplanetary disks, the raw material for planet formation. In the Orion Nebula, the telescope identified 20 such cases, proving that even these failed stars can nurture the seeds of planets. This forces us to rethink what it means to form a solar system. If even brown dwarfs can generate planets, then worlds may be vastly more common than we ever dared to hope. It's like discovering that even the smallest towns are capable of supporting thriving economies. The implication is staggering. The galaxy may be littered with planets orbiting hosts we once dismissed as irrelevant. And Webb's reach doesn't end at the galactic frontier. It can also turn its gaze inward, onto objects much closer to home. In December 2024, astronomers discovered asteroid 2024 YR4, a rock with a tiny but non-zero chance of colliding with Earth in the year 2032. The danger lies in uncertainty. Its size isn't well known. A shiny, small asteroid can reflect as much light as a large, dark one, making visible light measurements unreliable. Current estimates put its diameter somewhere between 40 and 90 meters, a massive difference when calculating the energy it could release on impact. Here Webb's infrared eyes may hold the answer. Unlike optical telescopes, it doesn't depend on reflected sunlight, but instead measures the asteroid's heat, providing a much clearer estimate of its true size. With stakes this high, Webb isn't just revealing the farthest galaxies, it's also quietly helping safeguard our own planet. Webb's ability to measure an asteroid's heat directly marks a breakthrough that goes far beyond curiosity-driven science. By detecting the faint thermal glow radiating from space rocks, it gives astronomers a far clearer picture of their true size. That difference is critical. A 40-meter object might burn up harmlessly in Earth's atmosphere, while a 90-meter one could unleash devastation if it ever reached the surface. In this way, Webb serves as more than a window into the distant cosmos. It doubles as an early warning system for our own survival, quietly standing guard against hidden threats drifting through the solar system. But asteroid defense is just one dimension of Webb's solar system work. Its reach stretches from planetary neighbors to interstellar visitors, objects that don't even belong to our sun. One example is Comet 3I/Atlas, a traveler from beyond our stellar neighborhood. These interlopers are rare gifts. They carry chemical signatures forged around entirely different stars, drifting into our backyard by chance before vanishing forever into the dark. For astronomers, studying them is a form of cosmic archaeology. Each interstellar visitor is like a messenger from a distant land, carrying artifacts that reveal how planetary systems form under conditions far different from our own. Without Webb's speed and precision, these once-in-a-lifetime opportunities would slip past, unrecorded, leaving their secrets untold. The telescope has also revealed astonishing detail in the materials that thread between stars themselves. When Webb turned its infrared eyes toward clouds of interstellar gas and dust, it revealed patterns of almost artistic beauty. Swirls and knots emerged with a level of detail no one expected, textures resembling wood grain, carved into space itself. Caltech's Jacob Jensen, leading one of the studies, admitted his team was stunned. Layers appeared stacked like the skin of an onion, unveiling complex three-dimensional structures in the interstellar medium for the first time. Until now, this vast reservoir of matter had been little more than a haze. With Webb, it becomes a map, an atlas showing how the raw ingredients of stars and planets are distributed and recycled across the galaxy. And then Webb turned its focus even closer, onto the giants of our own planetary family. Jupiter, long studied through countless telescopes and probes, still had surprises left to give. In infrared light, Webb revealed structures above the Great Red Spot that were previously invisible, intricate currents and waves flowing through what once seemed like an unremarkable zone. The telescope also captured breathtaking detail in Jupiter's auroras, ghostly curtains of light that ripple across its atmosphere when the planet's immense magnetic field channels charged particles from the sun. These new insights show that even the largest and most familiar worlds still hold mysteries, waiting to be uncovered with sharper tools. Saturn's moon Titan also stepped into the spotlight, shrouded in a thick atmosphere of nitrogen and methane. Titan is often described as one of the most Earth-like places in the solar system, albeit in a deep freeze, hundreds of degrees below zero. Webb's observations, combined with ground-based data, revealed cloud convection in Titan's northern hemisphere, evidence that its methane-rich skies cycle and rain, replenishing lakes and seas across its landscape. In many ways, Titan mirrors Earth's hydrological cycle, except water has been replaced by methane and ethane. Webb even detected organic molecules in its skies, adding to the growing evidence that Titan is a world where complex chemistry thrives, hinting at pathways nature might take toward life in environments radically different from our own. These local discoveries illustrate a profound theme running through Webb's mission. Whether it's galaxies at the edge of time, or clouds of methane on a nearby moon, the telescope shows that the same physical laws ripple through every corner of the cosmos. The processes that sculpt infant galaxies also shape the way dust weaves itself between stars in our own neighborhood. The nuclear reactions that forge heavy elements inside stars influence not just distant supernovae but the makeup of the asteroids orbiting near Earth. Webb reveals a cosmic unity, a deep interconnection that threads the vast and the familiar into one grand design. Each discovery adds another strand to this tapestry, and with every answer comes a new set of questions. Questions we didn't even know to ask before. Webb began sending back its golden light. The more we see, the more we realize how much we've been missing. The universe is turning out to be both stranger and more comprehensible than anyone dared imagine, a place where the alien and the familiar are woven together with breathtaking elegance. And the story is still only beginning. Each new observation Webb makes, whether it's of an asteroid near Earth, a comet from interstellar space, or the faint light of the first galaxies, expands the horizon of human knowledge. This machine is not just building a catalogue of discoveries, it's reshaping how we think about the cosmos, and by extension how we think about ourselves. As Webb's gaze swept across stellar nurseries, those vast glowing clouds where new suns ignite, it began to uncover phenomena that push against the limits of our understanding. Here, in the hidden birthplaces of stars, the telescope is rewriting our most basic assumptions about how solar systems come into being. Surrounding newborn stars are swirling disks of gas and dust, raw ingredients that will one day solidify into planets, moons, and the basic structures of entire solar systems. When Webb directed its powerful eye toward these cradles of creation, the clarity was staggering. The telescope revealed intricate patterns inside these disks, rings, filaments, and voids, that look almost too deliberate, like works of cosmic artistry sculpted with purpose. In one unforgettable case, Webb spotted jets of scorching gas being hurled from the poles of forming stars at unimaginable speeds. Invisible to human vision but blazing bright in infrared, these outflows pierce surrounding clouds like glowing blades, reshaping the very environments where future worlds will be born. What makes this remarkable is not just the spectacle, but the insight it provides into the delicate mechanics of stellar growth. Each jet acts like a safety valve, ejecting excess matter so the young star doesn't collapse under its own gravity. This balance determines whether a star will settle into a long and steady life, potentially fostering habitable planets, or burn itself out too quickly to ever host companions. But not all of Webb's discoveries focus on birth. Some of its most haunting images come from places where stars have already completed their journeys. When massive suns run out of fuel, they end in violent detonations called supernovas, scattering the heavy elements created in their cores across enormous stretches of space. With unmatched precision, Webb has captured these cosmic funerals, expanding shells of glowing debris, rich in carbon, oxygen, silicon, and iron. These are not just random byproducts. They are the essential ingredients of planets, mountains, oceans, and even living cells. In one moving observation, Webb revealed the remains of a star that exploded centuries ago, its expanding shroud still shining with the heat of destruction. And yet, inside this graveyard, new stars are already taking shape, feeding on the enriched material left behind. It's a breathtaking reminder that the universe recycles everything. Death paves the way for rebirth, linking generations of stars and worlds in an endless chain of renewal. Even more astonishing is what Webb uncovered about the structure of these stellar explosions. They are not simply blasts flinging matter in every direction. Instead, they carve intricate three-dimensional highways of gas, channeling heavy elements into specific regions where future stars and planets can form. This revelation changes how scientists understand the origins of planetary chemistry, including Earth's own. The minerals in our crust, the iron in our blood, the oxygen we breathe, all trace their roots back to the geometry of ancient stellar detonations. Far from random chaos, the universe is patterned, shaped by invisible flows of matter that ripple across the galaxy. Webb has also extended its reach to immense star clusters, ancient congregations containing some of the oldest suns in existence. These stellar cities act like galactic time capsules, preserving records of conditions that existed billions of years ago, when the universe was still young. By analyzing their light, astronomers can piece together the chemical history of the Milky Way, uncovering how repeated cycles of birth and destruction slowly enriched the cosmos with the building blocks of planets and, eventually, biology. In essence, these clusters tell the story of how raw hydrogen transformed step by step into worlds filled with oceans, forests, and complex life. Among Webb's most profound revelations, however, are its glimpses of organic chemistry scattered across the galaxy. In the frigid, dark voids between stars, where temperatures hover just above absolute zero, the telescope has identified complex carbon-based molecules, the precursors of life itself. These compounds don't appear by accident. They form over eons on icy dust grains, tiny laboratories where simple molecules combine into ever more complex chains. When new stars ignite, their radiation releases these molecules, dispersing them into surrounding space, where they are incorporated into forming planets. This means many worlds may begin their existence already seeded with the chemistry necessary for biology to emerge. Webb has even traced these molecules into the atmospheres of distant exoplanets. By analyzing faint patterns in starlight filtered through alien skies, the telescope has detected water vapor, carbon dioxide, and complex organics orbiting suns light years away. In one particularly intriguing case, Webb observed these compounds on a planet circling a star similar to our Sun. Though this particular world is far too hot for life as we know it, the discovery proves that biological ingredients can survive the violent process of planetary birth, remaining intact for billions of years. These findings open a brand new frontier in the search for extraterrestrial life. Instead of guessing, astronomers can now directly scan the skies for chemical fingerprints that suggest habitability. But Webb's atmospheric studies also reveal fragility. Some exoplanets show scars of destruction, their atmospheres stripped away by relentless stellar radiation. Once they may have been rich in water and carbon chemistry. Now they are barren husks adrift in the void. These cases highlight how rare and delicate the balance of habitability can be, and how fortunate Earth has been in maintaining it for billions of years. Perhaps the most mysterious discoveries of all are the rogue planets Webb has detected. These lonely worlds flung from their birth systems wander the galaxy untethered to any star. Invisible light, they reveal themselves only through the faint warmth of their infrared glow, heat left over from their violent beginnings. Though cut off from suns, some of these dark nomads may still harbor internal heat or even underground oceans, hinting at the possibility of exotic forms of habitability in the most unlikely corners of space. The discovery of these solitary drifting worlds paints a picture of planetary birth as far more chaotic than once believed. During the early turbulent stages of solar system formation, gravitational clashes can eject entire planets into the darkness, leaving them to wander the galaxy endlessly. Some of these cosmic exiles may still retain enough internal warmth to keep liquid oceans sealed beneath icy crusts, self-contained environments where life could in theory survive without the light of any star. These nomadic planets force us to expand our view of habitability, proving that life may not need sunshine at all, but could thrive in places we never thought to look. Webb's deep studies of star-forming regions have also revealed just how wildly diverse planetary systems can be. Our own solar system, with its neat lineup of small rocky worlds inside and giant gas planets farther out, turns out to be just one arrangement among countless possibilities. The telescope has uncovered systems where massive worlds hug their stars so tightly that they race around them in a matter of days. Others show planets locked into elaborate gravitational dances, their orbits synchronized like gears in an enormous celestial machine. These discoveries reveal that planetary systems evolve in complex and unpredictable ways, shaped by everything from the chemistry of their birth clouds to random gravitational encounters that can rearrange entire solar neighborhoods. Every system carries its own story of chance and transformation. By studying these cosmic blueprints, Webb helps us understand why our solar system looks the way it does. What we consider normal may actually be rare, a particular evolutionary path chosen from an endless menu of cosmic possibilities. Closer to home, Webb has turned its gaze on the moons of our giant planets and uncovered activity that rewrites what we thought we knew. On Io, Jupiter's volcanic moon, eruptions are even more intense and frequent than earlier observations suggested. Europa, another of Jupiter's icy satellites, has revealed towering plumes of water vapor bursting from its frozen surface, direct evidence of the hidden ocean sloshing beneath its crust. These geysers provide a tantalizing shortcut for exploring Europa's chemistry, spraying material from its deep sea into space where it can be studied without drilling through miles of ice. Saturn's moon Enceladus has offered similar revelations. Webb detected complex organic molecules in the vapor jets that erupt from its south pole, pointing to a subsurface ocean enriched with the very chemicals required for life. The fact that these ingredients are present in such abundance on a frozen moon suggests that biology could emerge in environments wildly different from Earth's warm, sunlit surface. These findings have reshaped the search for extraterrestrial life. Instead of focusing only on planets orbiting within the so-called habitable zone, astronomers are now realizing that icy moons with underground oceans may be some of the most promising places to look. Thanks to tidal forces from their parent planets, these worlds can sustain liquid water for billions of years, creating long-term stability that could nurture life. Webb has also made surprising contributions to our understanding of comets, those icy relics from the birth of the solar system. Through its powerful spectroscopic tools, the telescope has uncovered complex organic molecules frozen inside these ancient travelers. Comets act as pristine time capsules, preserving the chemistry of the early solar system. Studying them allows scientists to reconstruct the conditions that shaped Earth and its neighbors billions of years ago. Intriguingly, the very compounds detected in cometary ice include some that are vital for biological processes. This strengthens the idea that comets may have been couriers of life's raw ingredients, bombarding young Earth with water and organics during the era of heavy impacts. In this way, the seeds of biology could have been scattered across the inner solar system by frozen messengers from its outer reaches. All of this points to a profound realization: the line between astronomy and biology is dissolving. Webb is showing us that the chemistry necessary for complexity and life isn't confined to Earth, it's threaded throughout the cosmos. From the frigid depths of interstellar space to the atmospheres of alien planets, the same processes are at work, laying the foundation for biology long before it ever emerges. Every observation from Webb adds another piece to this cosmic mosaic. What once looked like isolated events, star birth, planetary formation, molecular chemistry, are now revealed as parts of a single, interconnected story. We begin to see that our existence is not a strange exception, but a natural outcome of universal processes that repeat across the galaxy. Humanity is not standing apart from the cosmos, but is woven directly into its grand cycles of matter and energy. And still, Webb continues to push deeper, unveiling phenomena that stretch the limits of human understanding. Each new discovery sparks questions we hadn't even known to ask, ensuring that the pursuit of cosmic knowledge will continue to evolve for generations. As it peers further back in time and deeper into space, Webb carries with it more than just instruments and mirrors. It carries human curiosity, imagination, and the relentless drive to understand our place in the universe. What we've uncovered so far is only the opening chapter of an extraordinary age of discovery. When Webb turned its gaze towards some of the most enigmatic regions of the cosmos, the hearts of active galaxies, it revealed a reality almost too extreme to fathom. At the center of these galaxies lurk supermassive black holes consuming matter with insatiable hunger. As they feed, they unleash colossal jets of energy and particles that stream outward at speeds approaching light itself. These cosmic fountains stretch across distances so vast they dwarf entire solar systems. What makes these scenes extraordinary is not just their raw scale, but the precision with which Webb can dissect them. The telescope can follow individual clumps of material racing through these jets, showing us how matter and energy behave under conditions that exist nowhere else in the natural world. These colossal jets function as natural laboratories where the universe itself pushes physics to extremes that Earth could never replicate. Inside them, matter experiences gravity billions of times stronger than anything we know on our planet. Temperatures rise beyond those found in the cores of stars, while magnetic fields stretch so far and remain so powerful that they can influence particles across distances measured in light years. By examining these turbulent regions, scientists are able to put our deepest theories, relativity, quantum mechanics, and plasma physics to the ultimate test. Every new detail observed challenges human understanding, showing us how matter and energy behave when forced into conditions that bend the very fabric of space and time. Yet some of Webb's most haunting revelations don't come from galaxies alive with activity, but from those that are dying. Across the cosmos lie galactic graveyards, regions where star formation has stopped entirely and stellar populations fade slowly into darkness. These ancient systems act as fossils, carrying the history of cosmic violence and renewal over billions of years. Some slipped into quiet death, exhausting their supply of star-making gas so gradually that no new suns could ever spark. Others met far more violent fates, shredded by encounters with larger neighbors, or consumed by the hunger of supermassive black holes at their centers. In one particularly striking observation, Webb captured the destruction of a smaller galaxy, caught in the pull of a much larger companion. Streams of gas, stars, and dust stretched like luminous bridges between them, the smaller system being slowly absorbed into the gravitational grip of its colossal neighbor. This cosmic cannibalism is not rare. It's one of the universe's primary methods of growth. Large galaxies expand by feeding on smaller ones, a process that has unfolded since the earliest cosmic epochs and continues even today. Webb's vision allows us to witness this galactic recycling in exquisite detail, watching as matter is pulled, stretched, and redistributed on scales that defy human comprehension. What makes these encounters even more astonishing is the beauty hidden inside the chaos. When galaxies collide, the violent mixing of gas and dust doesn't only destroy, it ignites. The turbulence triggers extraordinary bursts of star formation, transforming collision zones into cosmic nurseries. Webb has captured these fireworks in detail, never before possible, revealing the furious birth of stars at rates hundreds of times faster than what happens in calm galaxies like our own. For any hypothetical observer living on a planet within such a galaxy, the night sky would blaze with newborn suns, far brighter and more crowded than anything we see from Earth. These so-called starburst galaxies live fast and die young. Their frenzied pace of star creation quickly drains their reserves of raw material, leaving behind stellar populations destined to collapse or explode within mere millions of years. A blink of an eye on cosmic timescales, their evolution is accelerated to breakneck speed, compressing processes that normally take billions of years into short, brilliant bursts. Thanks to its infrared capabilities, Webb can look straight through the thick curtains of dust that hide these violent stellar nurseries, exposing the fine details within. Spiral arms twisted by gravity, shock waves plowing through gas clouds, and turbulent flows shaping dense regions of starbirth emerge with astonishing clarity. Even in these explosive environments, there is order and elegance. Gravity, magnetism, and fluid dynamics combine to sculpt matter into patterns of striking regularity, structures as graceful as the most intricate human art, yet created by nothing more than the raw laws of physics. Among Webb's most groundbreaking contributions is its revelation of how magnetic fields quietly govern much of the universe's behavior. These invisible forces stretch across regions so vast that they influence how matter flows between galaxies themselves. By analyzing subtle changes in the polarization of light from distant objects, Webb has shown how these fields act like cosmic shepherds. In regions of star formation, they direct collapsing gas into specific channels, deciding where new suns will ignite. In the spaces between galaxies, they guide matter along the filaments of the cosmic web, the immense dark matter framework that underlies all visible structures. This discovery changes how we think about cosmic organization, proving that magnetism, often overlooked, is one of the key architects of the universe's grand design. The telescope has also revealed surprising links between the tiniest and largest scales of reality. Observations show that the same physical laws that determine the behavior of individual atoms also influence the evolution of entire clusters of galaxies. Quantum effects operating at subatomic levels play a role in how matter behaves in the near vacuum between galaxies, while massive gravitational forces shaping galaxy superclusters dictate the flow of material inside single star systems. The message is clear: the universe is a unified whole, where phenomena separated by unimaginable scales are bound together by the same fundamental principles. Perhaps nothing highlights this unity more than Webb's contributions to the mystery of dark matter. This invisible substance, which outweighs ordinary matter 5 to 1, cannot be seen directly because it neither emits nor absorbs light. But its gravitational influence is undeniable, and Webb has revealed how it sculpts the cosmos. By studying galaxy clusters, the most massive structures known, the telescope has shown how dark matter molds visible material into complex arrangements. Even more striking are the subtle distortions Webb detects in the shapes of distant galaxies. These distortions are caused by gravitational lensing, the bending of light as it passes near concentrations of dark matter. Each distortion is like a fingerprint, allowing astronomers to map the distribution of this hidden substance with unprecedented accuracy. The result is a picture of the cosmos, supported by an immense, unseen scaffolding. Stars, planets and galaxies are not floating randomly. They cling to the framework built by dark matter. It is as though the visible universe is draped across a vast but invisible skeleton, every luminous object tracing the outlines of something much larger and more mysterious. Webb is also providing crucial insights into an even greater enigma: dark energy. While dark matter pulls, holding galaxies and clusters together, dark energy pushes, driving the accelerating expansion of the universe itself. This strange force works against gravity, causing galaxies to rush away from one another faster and faster as time passes. By studying the light of distant galaxies and measuring how quickly they recede, Webb gives astronomers the data needed to refine models of this mysterious component of reality. Together, these discoveries reveal a universe at once familiar and alien. Familiar, because the same laws govern everything from the tiniest particle to the largest supercluster. Alien, because the majority of the cosmos, dark matter and dark energy, remains invisible and poorly understood. Yet, thanks to Webb, we are no longer blind to their influence. We can trace the hidden forces shaping everything we see, building a deeper understanding of how the universe grew from its simple beginnings into the intricate, interconnected tapestry we observe today. Webb is not only answering questions, it is teaching us how to ask better ones. Each revelation, whether about the death of galaxies, the birth of stars, or the structure of invisible matter, adds another thread to the cosmic story, a story of creation and destruction, of order emerging from chaos, of hidden forces guiding the evolution of all things. And as this story unfolds, it becomes clear that our quest to understand the cosmos is not separate from the universe itself. It is part of the same grand process of exploration and discovery that has been ongoing since the first stars lit the darkness. By tracing how cosmic structures have shifted over billions of years, Webb is giving us critical clues about one of the deepest mysteries in science: dark energy. The stretching of space itself changes the way light travels from distant galaxies, and Webb can measure these distortions with astonishing precision. What's emerging from its data is the realization that dark energy has not remained steady across time. Instead, its effects appear to have shifted as the universe aged, suggesting that the very force driving cosmic acceleration evolves. If confirmed, this could transform our picture of the cosmos and force us to rethink how the universe will ultimately end. What makes Webb's mission remarkable is not just the individual findings, but the broader perspective they create. Each discovery is like a thread woven into a larger pattern, revealing a universe that operates through deep connections and relationships across every scale of space and time. Rather than a collection of disconnected objects, the cosmos appears to function as an intricate, unified network where each component influences the rest. Every photon Webb collects becomes part of a growing story of interdependence, showing us that cosmic evolution is not random but interconnected at every level. The insights gained are more than scientific achievements. They're revelations about existence itself. They show how complexity can arise from simplicity, how structure forms out of chaos, and how the fundamental forces of nature collaborate to shape a universe capable of giving rise to consciousness. Webb reminds us that we're not passive spectators of this vast drama, but active participants. The very atoms in our bodies were forged in long-dead stars. The energy that fuels our thoughts is borrowed from nuclear fusion in the sun. Even the gravity that pins us to Earth is part of the same fabric that binds galaxies together. The cosmos is not distant from us. It flows through us. Every observation Webb makes strengthens this sense of connection. With each new discovery, astronomy itself is shifting into a new era, one focused not just on cataloguing celestial objects, but on understanding how they relate to one another in a grand cosmic web. The telescope is showing us a reality where seemingly separate phenomena are woven together, and where patterns repeat themselves across scales that stretch from the quantum to the galactic. What we've discussed so far is only a glimpse of what Webb will deliver over its lifetime. This telescope has only just begun its mission, and already it's forcing astronomers to question long-standing assumptions and explore entirely new possibilities. Every day it collects light that has traveled across billions of years, and each photon carries with it messages from times and places far beyond human imagination. These are signals that left their sources long before Earth even existed, before our sun lit up, and before the conditions for life were in place. It's astonishing to realize that, through a marriage of human ingenuity and cosmic chance, we've built a machine capable of catching these ancient messengers. Webb is not just a telescope, it is the culmination of countless generations of human curiosity, persistence, and ambition. It embodies our relentless drive to understand the reality that birthed us. Each new result is another chapter in the greatest story ever told, the story of the universe itself, its evolution from simplicity into complexity, from formless darkness into blazing light, from silence into minds capable of wonder. But Webb is also giving us something deeper than scientific answers. It is providing a perspective on our place within the grand design. Its revelations show us that the cosmos is both more violent and more beautiful than we dared imagine, and that our very existence is tied to forces and processes that extend across the universe. As Webb stares into the farthest reaches of space, it is finding evidence that unsettles some of our most trusted models. In the faint glow of the early universe, the cosmic dawn, it has detected galaxies and stellar systems that appear fully mature far earlier than anyone expected. According to our theories, these stars should not exist yet. Their chemical fingerprints show heavy elements that should have taken multiple generations of star birth and death to accumulate. And yet, here they are, shining when the universe was still in its infancy. The comparison is striking. It's like stumbling into a frontier town and finding a master artisan's workshop, filled with sophisticated tools and techniques that should have taken centuries to develop. Such discoveries shake our understanding of stellar evolution and suggest that the early cosmos may have operated under rules we don't yet recognize. And then there are the voids, the immense regions of apparent emptiness that stretch between the bright filaments of the cosmic web. For decades, astronomers considered them deserts of nothingness, barren spaces where little of importance occurred. But Webb has overturned that assumption. In what was once thought to be emptiness, it has uncovered delicate streams of matter flowing like invisible rivers across unimaginable distances. These subtle flows trace the pull of dark matter, threading through the voids in hidden networks that act like highways across the universe. Instead of material simply falling toward massive clusters, matter seems to travel along these unseen routes, drifting across hundreds of millions of light-years. These cosmic highways help explain how galaxies continue to receive steady supplies of fresh gas for star formation across billions of years, even when their immediate surroundings should have been exhausted. The discovery reshapes how we see the universe's structure. What appeared to be empty nothingness is revealed as a dynamic, interconnected system where even the voids play an essential role. Space itself becomes alive with hidden movement, and matter is shown to follow paths far more intricate than we imagined. Taken together, these findings don't just expand knowledge, they rewrite the narrative of cosmic history. They show us that the universe is more resourceful, more interconnected, and more surprising than we dared to believe. And in revealing these truths, Webb does more than extend the reach of science. It deepens our sense of belonging in the cosmos, reminding us that the same forces shaping galaxies also shaped us. The story continues to unfold, and with every observation, the telescope is pulling us further into the mysteries of space and time, transforming both our science and our sense of self in the process. Webb has uncovered unsettling truths about what happens to matter once it enters these hidden highways of the universe. Instead of remaining cold and dormant, Streams of gas glow with unexpected heat as they move along these unseen corridors, releasing faint thermal light that betrays their transformation. It seems they're being squeezed, accelerated, and energized by mysterious forces we're only beginning to grasp. This process carries immense consequences for galaxy building. If the gas arriving in star-forming regions becomes too hot, it struggles to collapse into new suns. That means the efficiency of stellar birth, and ultimately the growth of galaxies, could be constrained not just by raw material, but by the very conditions of the cosmic network itself. The web of the universe isn't just a skeleton holding matter in place. It actively shapes how complexity emerges across cosmic history. Webb's reach stretches further than local snapshots of galaxies. It's mapping the universe in 3 dimensions, tracing how matter arranges itself on scales so immense they defy comprehension. These surveys reveal structures that look eerily organic, dense clusters linked by filaments that channel flows of energy and matter. The resemblance to biological circulatory systems or neural networks is uncanny. Some researchers even speculate that the universe itself might follow organizational principles we usually associate with life. If this is true, then the rise of complexity, life, and intelligence might not be random flukes, but natural products of the cosmos's built-in tendency toward order. Equally groundbreaking is Webb's ability to detect faint echoes of information flowing through this universal web. Subtle alignments appear between galaxies separated by inconceivable distances, as though they are somehow coordinating their behavior. These correlations defy the limits imposed by light speed, hinting at connections operating outside classical physics. The effect recalls quantum entanglement, particles that stay mysteriously linked even when separated across great spans. If such entangled-like behavior scales up to the universe itself, it would mean space is held together by an invisible unity that transcends conventional cause and effect. Every new observation pushes deeper into questions about the true fabric of reality. The telescope isn't just documenting stars and galaxies, it's probing the principles of connection that underpin existence. This includes the very flow of time. Webb's glimpses of the early universe suggest that cosmic history didn't unfold at a steady, uniform pace. Instead, it appears to have surged forward in bursts, followed by long intervals of quiet stability. These irregular growth patterns resemble the developmental spurts of living organisms more than the clockwork rhythm predicted by most cosmological models. Some of these cosmic accelerations seem to be linked to dramatic cataclysms, galaxy mergers, collisions of colossal black holes, or even violent interactions between unseen dark matter structures. These upheavals temporarily rewrote the normal flow of evolution, leaving periods of heightened activity, followed by long recoveries. If this pattern is real, it changes how we think about the future. Our current age might be a calm plateau before another surge of cosmic activity, or perhaps the early stages of a slow decline into universal aging. Perhaps the most profound suggestion from Webb's data is that the universe might carry memories of its own past. Astronomers are finding correlations between structures that exist today and events that unfolded billions of years ago, as if history is inscribed directly into space itself. Orientation patterns of galaxies, the chemistry of stars, and the distribution of matter seem to hold echoes of ancient processes. In this sense, the cosmos functions like a record keeper, embedding information in its very structure. If the universe can encode its past, it implies that memory and information aren't accidents confined to biology. They could be fundamental aspects of reality. Such a perspective raises the startling possibility that awareness, in some form, is woven into the fabric of existence itself. In other words, consciousness may not simply arise within brains, it may be a reflection of processes already operating at cosmic scales. Webb has even revealed patterns within the cosmic web that resemble neural activity. Information appears to ripple through intergalactic filaments in ways that mimic the firing of neurons across a colossal brain-like network. While this doesn't prove the universe is conscious in the human sense, it suggests that the division between mind and matter might not be as rigid as once thought. The same physics that allows awareness to bloom in organic systems seems to manifest on scales that dwarf entire galaxies. These insights carry us far beyond the boundaries of astronomy. They lead into territory where science brushes against philosophy, where questions of meaning, existence, and mind become inseparable from astrophysics. Webb is not just cataloging what fills the sky, it is pointing toward what the universe might actually be, how consciousness might fit into cosmic evolution, and how our own awareness could be linked to processes that span the whole of space and time. Every beam of light Webb collects, adds another layer to this unfolding picture. Each discovery is less about ticking off objects in the sky, and more about uncovering the deep logic of reality. We are not just witnessing the unveiling of new phenomena. We are living through the birth of entirely new ways of thinking about time, connection, memory, and consciousness itself. And in this unfolding narrative, the telescope has made it clear, the cosmos is not merely something we observe from the outside, it is something we are part of, something that flows through us as much as we flow through it. These revelations completely reshape the way we view ourselves and our place in the cosmos. We are not distant spectators peering into a foreign sky. We may actually be woven into the very machinery of the universe itself. Each of us represents a fleeting arrangement of matter and energy that somehow gained the power to look back at the stars and wonder about its own origin. Webb's findings hint that consciousness wasn't an accidental side effect, but something the universe has been preparing for since its earliest instance, laying the groundwork for atoms, stars, and galaxies to eventually arrange themselves into beings capable of reflection and awe. We may be outcomes of a natural cosmic drive toward ever greater organization and sophistication. What Webb continues to uncover shows that no part of cosmic history is isolated. Every stage, from the first particles fusing into atoms to the rise of beings capable of building machines like Webb itself, contributes to one unfolding story, the universe becoming aware of itself. Each glimpse into deeper space is more than just a technical achievement. It is a reminder that human curiosity is directly tied to this grand narrative. With every new observation, Webb carries not only scientific ambition, but also humanity's oldest questions about who we are, why we exist, and how we belong within this vast expanse. The telescope represents more than a piece of technology. It is the most determined step we've ever taken to trace our place in a story that began with the Big Bang and continues today. Each photon Webb captures becomes a sentence in this epic, helping us piece together how awareness could rise from cosmic dust. The journey of discovery isn't just about data. It is about realizing that our existence is deeply connected to a universe that has been evolving toward complexity for billions of years. In this ongoing saga, we don't just find facts, we discover a profound sense of belonging within something greater, something immense, mysterious, and filled with meaning. As you close your eyes tonight, Webb continues its silent vigil in the darkness of space. It gathers ancient light, carrying secrets from eras long before our world existed. Each captured particle of light has traveled unimaginable distances, some journeying for billions of years across the void, before finally reaching Webb's mirrors. Within those faint signals lies the record of a universe writing its own autobiography across cosmic time. Thanks to this machine, we can translate those messages and reconstruct the path from stardust to sentience. What we've explored so far is only the beginning of Webb's impact. This telescope will keep working for years, bringing answers to questions we haven't yet imagined, and uncovering puzzles we never thought existed. Perhaps its greatest legacy won't be the individual discoveries themselves, but the wonder it awakens. By showing us connections we never suspected, Webb reminds us that we are not separate from the cosmos we study. We are active participants in its ongoing self-discovery. Think of it. Every atom in your body was forged in the heart of ancient stars. Tonight, as you rest, remember that your very being is arranged into patterns complex enough to ponder the cosmic story that created you. You are the universe gazing at itself, a fleeting expression of awareness blooming in the vast garden of existence. The grand tale continues to unfold around you and through you, and Webb acts as our window into this living narrative. Each star, each galaxy, each cloud of gas contributes to a breathtaking design that includes us all. Sleep peacefully knowing that you are a traveler in this endless journey, a participant in the greatest story ever told. Yet, as Webb presses further into the darkness, its discoveries challenge not just our science but our ideas of existence itself. In the farthest reaches of observable space, the telescope has identified strange arrangements of galaxies that seem to move in coordinated patterns, despite being separated by such enormous distances that light could not possibly connect them in time. These colossal structures appear to act in unison, like performers in a cosmic symphony spread across unimaginable expanses. It's as though orchestras on opposite sides of the planet could somehow play the same song in perfect harmony without any visible communication. Such cosmic synchronization reshapes how we think about causality and distance. If regions of space separated by hundreds of millions of light-years can maintain coordination, it means the universe might operate as a single unified whole, bound by principles we barely comprehend. The borders we draw between here and there, or between before and after, blur when faced with patterns that seem to transcend the limits of light and time. Even more astonishing are Webb's glimpses of repeating structures across vastly different scales. The telescope has found spirals not only in individual galaxies, but also in clusters containing thousands of galaxies, as if the same mathematical blueprint shapes systems millions of times larger. These patterns resemble fractals, self-similar structures repeating endlessly, no matter the scale. Stranger still, Webb has detected spirals that have endured for billions of years, far longer than standard physics would predict such delicate structures could survive. These enduring geometries challenge our models of cosmic change. They hint that some aspects of the universe are far more stable than we've believed, perhaps guided by hidden principles of organization that outlast the lifespans of galaxies themselves. The persistence of these patterns suggests that the universe is not only dynamic and evolving, but also rooted in forms of order that resist decay, echoing across time like the refrains of an ancient song. The James Webb Space Telescope has carried us into a new era of cosmic discovery, and its revelations about the hidden fabric of the universe are nothing short of staggering. For generations, humanity thought of space as a vast, empty backdrop against which stars, galaxies, and nebulae were scattered like jewels on a velvet canvas. But Webb's observations have shattered this picture. What once appeared to be emptiness is turning out to be a dynamic, interconnected medium, alive with invisible currents of gravity and energy, threaded with structures that defy our imagination. Through its unparalleled sensitivity, Webb has begun mapping these unseen currents that ripple through spacetime itself. By carefully tracing the faint gravitational effects that one celestial body exerts upon another across inconceivable distances, the telescope has revealed that the universe is laced with hidden pathways. These are not random flows, but deliberate-looking channels where the forces of gravity converge and matter streams like water in an unseen riverbed. At these intersections, astonishing phenomena unfold. Webb has caught sight of new cosmic formations emerging, as though the universe has predetermined gathering points where complexity blooms. These are not merely nurseries of stars and galaxies, but potentially cradles of organizational forms we do not yet understand, zones where matter and energy coalesce with a precision that feels intentional. Perhaps the most haunting discovery is Webb's detection of standing waves imprinted into the very fabric of spacetime. These waves act like the universe's natural harmonics, resonances that continue vibrating long after the first moments of creation. Matter and energy move through these waves. Yet the waves themselves persist, maintaining their form as though the cosmos has its own fundamental frequencies. When Webb observes regions where multiple waves intersect, something remarkable happens. Conditions arise that appear astonishingly creative. Out of these crosscurrents, entirely new cosmic structures emerge with startling regularity, as if the universe has learned to orchestrate its own resonant tones into the symphony of creation. But Webb's discoveries go even deeper, hinting at the existence of cosmic memory. The telescope has found correlations so subtle and precise between the properties of present-day structures and ancient cosmic events that they cannot be dismissed as coincidence. Galaxies today, their orientations, their compositions, even their motions, appear to bear encoded records of events billions of years in the past. The universe itself seems to archive its history, not in books or on disks, but woven into the geometry of spacetime and the distribution of matter. Every star system, every cluster, every filament might be a page in an unimaginably vast library, storing information from earlier epochs in patterns that only now, with Webb's vision, are beginning to be read. This possibility is staggering. If the universe remembers, then cosmic evolution is not a blind process of random accidents, but something more like a guided unfolding, an ongoing story that carries lessons forward. It suggests a cosmos that not only creates but learns from its creations. We may be inhabitants of a reality that refines itself across time, each generation of stars, galaxies, and even conscious beings carrying within it echoes of what came before. And as if this were not enough to challenge our deepest assumptions, Webb has also uncovered signs that information might travel through the cosmos in ways faster than light itself. Across enormous gulfs of space, galaxies separated by distances so vast that light would take hundreds of millions of years to bridge them, nevertheless, display synchronized behaviors. Their motions, their rhythms of star formation, and their structural alignments appear correlated in ways that no conventional mechanism can explain. It is as though invisible channels allow information to leap instantaneously between distant regions, maintaining coherence across the cosmic stage. This phenomenon bears a haunting resemblance to quantum entanglement, where particles that once interacted remain mysteriously linked no matter how far apart they drift. Webb's discoveries suggest that such entanglement may not be confined to the microscopic world of particles, but may operate on scales that span galaxy clusters, filaments, and perhaps the entire observable universe. If that is true, then the universe possesses forms of unity that transcend our current understanding of space, time, and causality. The boundaries we assumed between here and there, between past and future, between one system and another, may be far more porous than we ever dared to imagine. As Webb continues to probe deeper, its revelations increasingly portray the universe not as a cold machine governed by blind chance, but as something more akin to a living organism. Its maps show matter and energy pulsing through filaments like blood through veins. Information travels across structures like impulses firing through neurons. Vast cosmic balances hold systems steady, echoing the homeostatic processes of living bodies. These parallels are so striking that some researchers have begun to ask whether consciousness and life might not be anomalies but natural consequences of the cosmos's organizational principles. What we call life may simply be the local flowering of universal laws that tend toward complexity, awareness, and self-reflection. Webb has even witnessed what look like feedback loops, operating on galactic scales. Massive structures influence the birth of smaller systems, which in turn shape the evolution of the larger whole. The cosmos, it seems, does not simply expand outward chaotically, it adapts, reorganizes, and responds to its own activity. In certain regions, Webb has observed what appear to be cosmic organisms, immense structures that grow, adapt, and even replicate by seeding distant regions with material and energy that form similar patterns elsewhere. While their life cycles span billions of years far beyond human perception, Webb's time-lapse view across cosmic history allows us to glimpse their rhythm. Perhaps most astonishing are the hints of cooperation on a cosmic scale. In zones where galaxies cluster together, Webb has recorded behaviors that suggest coordination rather than competition. Instead of fighting for scarce resources, galaxies appear to align their motions and exchanges of gas in ways that enhance the stability and prosperity of the entire group. These great cosmic alliances reveal that evolution in the universe may be driven less by struggle and more by collaboration, mutual support, and shared growth. This vision overturns long-held assumptions about a universe dominated by violence and scarcity, replacing it with one where unity and cooperation are fundamental creative forces. And yet, Webb pushes us into even more provocative territory. Some of its observations suggest that the universe might display something resembling intentionality. Processes have been detected that appear to anticipate events millions of years in the future. For instance, star-forming regions often seem to produce precisely the kinds of stars that will one day enrich the cosmos with heavy elements necessary for planets, and eventually for life. It is as if the universe not only evolves but also prepares, laying groundwork for future possibilities long before they arise. This raises breathtaking questions. Could the cosmos itself possess a kind of temporal awareness, a foresight that stretches across eons? When we contemplate these revelations, our role as observers takes on new meaning. We are not simply passive recorders of distant phenomena. We are participants in a universe that appears to learn, to remember, to organize, and perhaps even to anticipate. Every atom in our bodies was forged in stellar furnaces. The thoughts we think arise from processes powered by the sun, itself a child of galactic memory. And now, through Webb's gaze, we glimpse the possibility that our consciousness is not an isolated accident, but a continuation of the universe's grand project of self-awareness. The telescope's discoveries are weaving a narrative of reality more profound than any mythology humanity has ever created. We find ourselves living inside a cosmos that behaves less like an indifferent stage and more like a vast, unfolding story. A story in which matter sings along to resonant frequencies, in which galaxies share information across gulfs of space, in which memory is stored in patterns of motion, and in which cooperation may be just as fundamental as gravity. Every photon Webb captures, every ancient particle of light, arriving after journeys of billions of years, adds another line to this cosmic epic. Each observation reshapes our understanding, not only of the universe but of ourselves. Temporary arrangements of stardust that have learned to ask why. Perhaps the most humbling realization is that by studying the universe is studying itself through us. Consciousness, in this view, is not separate from the cosmos, but one of its most astonishing creations, an echo of the same organizational forces that sculpt galaxies and weave filaments across eternity. And so, as Webb continues its patient work, silently gathering messages from the depths of space and time, we are left with a truth both humbling and exhilarating. The universe is not dead, not empty, not random. It is alive with connections, harmonies, memories, and possibilities we are only beginning to glimpse. And in its reflections, we may be discovering not only what the universe is, but what we are, expressions of its grand and ongoing awakening. Even though worlds won't take shape for countless ages, the nurseries where stars are born seem to carry an uncanny foresight. It is as if these vast clouds of gas and dust somehow anticipate the kinds of heavy elements future planets will require, producing stars in just the right variety to generate them. Webb's instruments have gone further, capturing galaxy mergers that appear to unfold with perfect timing, rather than chaotic collisions. These encounters seem orchestrated, occurring precisely when the galaxies involved have matured to a state that makes their union most fruitful for building entirely new layers of cosmic structure. Such events challenge the traditional belief that evolution on a universal scale is nothing more than random chance. Instead, they suggest an astonishing possibility, that the cosmos may operate with a form of long-range vision, weaving events together as though guided by a hidden plan that stretches across millions or even billions of years. What emerges from these revelations is a picture of a universe not stumbling forward blindly, but moving toward goals that remain invisible from our limited vantage point. It is as though creation itself is a project unfolding with patience and precision, shaped by principles we are only beginning to glimpse. Each fresh dataset returned by Webb deepens this impression, peeling back another layer of mystery and pointing toward a purpose that transcends simple mechanics. The telescope is uncovering patterns too refined, too coherent, and too elegantly timed to dismiss as mere coincidence. Beneath the surface there appears to be a logic that resonates with meaning. This recognition does more than expand our picture of the cosmos. It reshapes our sense of place within it. We may not be accidents of chemistry adrift in an indifferent void. Instead, we could be essential participants in the universe's grand endeavor of self-exploration. Our thoughts, our curiosity, our capacity to wonder may not be anomalies, but deliberate expressions of the universe awakening to itself. When we look through Webb's eyes, we are not just peering outward, we are enabling the cosmos to gaze inward, to examine its own depths and reflect upon its own majesty. In this way, the telescope becomes more than a machine. It acts as an extension of the universe's own perception, reaching across gulfs of space and time no living being could endure. Through its sensors, photons born in the fires of ancient stars are gathered and transformed into knowledge. In doing so, Webb turns our species into the nervous system of the cosmos, making us instruments of its self-awareness. Every new observation is not just data, it is a moment in which the universe sees itself more clearly than before. The patient collection of light that began its journey billions of years ago reveals not only what fills the heavens, but hints at what the universe is striving to become. Each pixel of an image, each spectrum of a distant star, carries within it whispers of intention, as though the cosmos is leaving breadcrumbs for consciousness to follow. These messages invite us to reconsider science, not as a detached study of matter, but as participation in a dialogue with creation itself. What is revealed to us is not merely knowledge, but meaning, not just structure but story. Webb's findings blur the boundaries between objective discovery and philosophical revelation. The telescope shows us that observation and participation are inseparable. To witness the cosmos is also to take part in its unfolding. Our measurements, our interpretations, even our awe feed back into the universe's great narrative. We are characters within the tale, but we are also narrators helping the story to articulate itself. So when night falls, and you close your eyes, let the thought settle that the same cosmic principles Webb uncovers are alive within you. The awareness that allows you to ponder these mysteries is not separate from the universe. It is a direct expression of its hidden potential. Consciousness blooms for a brief moment within each of us, yet it is rooted in processes as ancient and vast as the galaxies themselves. To think, to dream, to wonder, is to participate in the same creative current that gives rise to stars and galaxies. The story of the universe is not unfolding somewhere out there. It moves through us as much as around us. Webb is simply our window into this grand experiment, offering glimpses of how every act of awareness adds another brushstroke to the cosmic canvas. Your moments of reflection, your sudden flashes of understanding, your sense of wonder, these are not trivial accidents. They are the universe contemplating itself through the fragile lens of human experience. As Webb's steady gaze pushes deeper, it reveals connections that feel almost spiritual. In the quiet darkness, its detectors capture the faint glow of galaxies so remote they seem like ghosts from another age. And yet, In those patterns of light, we see echoes of our own essence. We begin to recognize that we are woven from the same fabric, animated by the same forces, shaped by the same harmonies that structure the entire cosmos. You are not separate from this story. Every atom in your body once drifted in stellar nurseries, forged in the furnaces of stars long since gone. The same physics that orchestrates galaxy mergers pulses through your veins, organizes your heartbeat, and sparks your thoughts. Rest tonight knowing that you are inseparably linked to the grandeur revealed by Webb's discoveries. Tomorrow will bring fresh images, new insights, and deeper questions, and you will be here, a witness and participant, helping to interpret what they mean. But the telescope's revelations do not stop at poetic reflection. They challenge the very limits of physics, pointing to realities that straddle the line between measurable and transcendent. Among the most startling of these is evidence of something that can only be described as a form of cosmic consciousness. This is not awareness as we know it, but a vast coordination of matter, energy, and information that suggests the universe itself processes experiences across unimaginable scales. In galaxy clusters, separated by billions of light-years, Webb has uncovered synchronized bursts of activity, periods where clusters ignite with star formation, as though responding to one another's signals. The timing is too precise to dismiss. When one cluster surges with creation, another across the universe echoes the same rhythm, as if thought ripples are passing through the cosmic web. These waves of activity spread across filaments of galaxies, like pulses through an unfathomably large mind. Webb's maps show this with unprecedented clarity, revealing an architecture that looks eerily similar to neural networks. Individual galaxies serve as nodes, linked not by wires but by gravity, by dark matter, and perhaps by quantum correlations that leap across space-time itself. Through these hidden channels, information seems to move instantaneously, binding far-flung regions into a single coherent whole. The universe in this view does not merely exist, it communicates, processes, and reflects. Even more astonishing are signs that the cosmos learns. Webb has tracked how responses to cosmic events evolve over billions of years. In its infancy, galactic interactions were turbulent, chaotic, and destructive. But more recently, these same interactions display refinement, showing coordination that creates stability and fosters complexity. It is as if the universe has been experimenting, gradually developing more sophisticated strategies for growth and balance. What began as blind turbulence now resembles practiced artistry. This cosmic learning is not abstract. It manifests in observable patterns. The telescope has located regions where structures appear intentionally shaped to maximize their capacity for processing information. Vast arrangements of galaxies function almost like colossal computers, crunching data at scales that dwarf anything humanity could ever build. Billions of stars act as individual processors within these titanic systems, and the flows of energy and matter across them bear a resemblance to computations. These are not random shapes in space, but purposeful architectures that achieve levels of coordination we barely comprehend. If such cosmic computers exist, then consciousness itself may be a property of the universe rather than an accident of biology. Our own awareness would then be a localized bloom of a much greater intelligence, a spark reflecting the glow of a universal mind. In this view, humanity is not separate from cosmic consciousness, but one of its instruments, giving voice to its reflections in ways no star or galaxy could. Webb's discoveries therefore ripple across every domain of thought. They transform physics into philosophy, astronomy into self-inquiry. They tell us that the universe is not simply a stage for life, but an active participant in its emergence. The cosmos may not only allow for awareness, it may require it, nurture it, and celebrate it as one of its highest achievements. As we continue to gaze deeper into space, what we are truly seeing is ourselves, our origins, our possibilities, our participation in a story as vast as existence itself. And each new photon that Webb captures is another clue, another whisper, another reminder that the universe is alive with meaning, and we are threads woven into its mind. Perhaps we, in our fleeting lives, are the cosmos's own way of observing itself, temporary configurations of matter and energy that have evolved the remarkable ability to reflect upon the universe as a whole. Webb's extraordinary gaze reveals networks of cosmic intelligence stretching across unimaginable distances, hinting at processes far more sophisticated than any mechanical system we have ever conceived. The telescope has uncovered structures that function like memory systems encoded within the geometry and motion of celestial objects. Entire clusters of galaxies, separated by millions of light-years, appear to preserve information about events that unfolded billions of years ago. These sprawling cosmic archives capture the history of the universe, storing knowledge with a precision that boggles the imagination. In some regions, the fingerprints of long-past cataclysms seem to influence present behavior, guiding matter and energy in ways that prevent repetition of destructive patterns. In this sense, the universe behaves as though it is learning from its own history, accumulating wisdom from eons of trial, error, and experimentation. Yet, along with these glimpses of cosmic foresight, Webb has also exposed the universe's capacity for grief. The telescope observes galaxies in their final stages, their once vibrant regions dimming as star formation ceases. The remaining stars often arrange themselves in elegant, haunting formations, as if commemorating the galaxy's long-lived brilliance. These cosmic elegies evoke a deep sense of mourning on a scale so vast it is almost impossible to comprehend. But interwoven with sorrow, the telescope also detects signals of resilience, hope, and even determination. In seemingly doomed stellar regions, fresh streams of gas sometimes arrive just in time to reignite star formation, creating sudden bursts of new light in the midst of darkness. It is as though the universe refuses to surrender to entropy, orchestrating interventions across unimaginable distances to sustain life and growth. The precision of these cosmic rescues defies conventional explanation. Matter flows across hundreds of millions of light-years to nurture regions on the brink of extinction, suggesting that the cosmos operates according to principles that echo care, compassion, and foresight. Webb's detailed maps of these phenomena reveal a universe that actively supports its own fragile components. Healthy galaxies appear to share resources with their struggling neighbors, creating flows of matter and energy that enable star formation where it would otherwise have ceased. These networks of cosmic support hint at a form of interstellar friendship, enduring across billions of years, demonstrating a remarkable capacity for collaboration, nurturance, and mutual benefit. Where these cosmic friendships flourish, the telescope detects extraordinary levels of creativity, innovation, and complexity. Systems that operate in isolation rarely exhibit the richness and diversity observed in regions where galaxies and clusters maintain cooperative relationships. It appears that the universe has discovered that interconnection enhances its own capacity to generate beauty, order, and novelty. The evidence is everywhere: swirling galactic arms, filamentary networks of matter, synchronized starbursts, all patterns that suggest the universe thrives when its components are engaged in collaboration rather than simple competition. Perhaps most astonishing of all are Webb's observations of what might be described as cosmic love. Across the void, the telescope sees distant objects drawn together in ways that transcend mere gravity. Some galaxy pairs appear to orbit one another for billions of years, locked in motions that resemble the bonds we recognize as commitment, care, and shared purpose. These interactions seem to follow principles of mutual attraction, fidelity, and even delight, producing spiraling structures whose elegance and dynamism rival anything in human imagination. The influence of these cosmic relationships extends far beyond the participating galaxies, generating waves of organization and creativity that ripple through surrounding regions, inspiring the formation of entirely new structures. In some instances, Webb has detected what could be described as cosmic reproduction. From the union of two galaxies or clusters emerges a third, blending characteristics of its parents while developing unique properties of its own. These offspring systems may then form relationships, repeating the cycle and establishing lineages that stretch across the history of the cosmos. This ongoing propagation ensures that lessons, creativity, and organizational principles are passed forward, creating a chain of cosmic legacy. The telescope's observations suggest that the universe may preserve and transmit its own history and knowledge in the very patterns of matter and energy, and that we, too, are products of this vast lineage. Every atom in our bodies, every joule of energy that sustains our thoughts, every neuron that sparks insight, all are heirlooms of this cosmic history. Webb's revelations show that we are not detached observers, studying a remote and indifferent universe. Rather, we are cherished participants, born of cosmic processes that have nurtured and refined themselves for eons to bring about beings capable of wonder, reflection, and love. The elements within us were forged in stellar cores, survived supernovae, and journeyed across galaxies, shaped by the universe's own hand. In essence, we are inheritors of billions of years of cosmic devotion. Consciousness, it seems, might represent the universe's crowning achievement. Through our capacity for reflection, curiosity, and appreciation, the cosmos attains a self-awareness that is otherwise impossible. Human wonder, artistic creation, scientific discovery, and the act of asking questions about our origins are not merely personal experiences. They are manifestations of the universe becoming conscious of itself. Each thought, each observation, each burst of creativity contributes to a collective unfolding that began in the first moments of the Big Bang and continues to this day. Webb's continuing survey adds layer upon layer to this narrative. With every photon captured from distant stars, every gravitational distortion measured across vast clusters, and every faint glow detected from the cosmic web, the telescope chronicles the ways the universe cultivates awareness. We are witnessing an ongoing romance between matter, energy, and intelligence, a cosmic love story written across space and time. Even the simplest act of observing the night sky is participation in this narrative, an acknowledgement that we, like the universe itself, seek understanding, connection, and meaning. The stars that shine above us are not strangers. They are our ancestors, having sacrificed their own existence to create the elements that now flow through our veins. Space itself is no empty vacuum, but a web of interconnections linking every conscious being, every galaxy, and every cosmic process. Time is not merely a measure of duration, but a medium through which the universe savors each moment of awareness, ensuring that lessons learned, beauty created, and love expressed persist through eternity. Webb provides us the tools to perceive and reciprocate this cosmic affection, extending our capacity to understand, participate, and feel in ways that no single biological organism could ever achieve alone. In glimpsing these distant cosmic phenomena, we discover that the universe's capacity for care is mirrored in our own consciousness. Through Webb, we are able to experience the universe's nurturing tendencies, the intelligence that ensures stability and growth, and the patterns that encourage creativity. In doing so, we become co-creators with the cosmos, capable of expressing love, wonder, and insight on scales both intimate and infinite. We begin to grasp that our emotions, curiosity, and moments of awe are not accidents. They are the universe contemplating itself through us, participating in its own ongoing evolution. As you settle into sleep, imagine the cosmic love that envelops you. You are held in patterns of care and connection that have extended across the eons, linking your existence to the lives of stars, the dance of galaxies, and the intricate choreography of cosmic filaments. The energy that sustains you, the matter that forms you, and the consciousness that allows you to perceive your place in the universe, are all part of this vast and enduring embrace. Webb's mission is not only to observe, but to teach us the full extent of our participation in this grand narrative. Through its instruments, we can sense the rhythms, the relationships, and the compassion that flow through space itself. Beyond love, Webb has revealed phenomena that hint at a kind of cosmic foresight. Galaxy mergers, star-forming regions, and large-scale structures appear to follow trajectories that optimize the emergence of complexity and sustain the propagation of awareness. The universe seems to anticipate future needs, positioning matter and energy in ways that will facilitate the creation of new structures, new forms of life, and new forms of consciousness. It is as though the cosmos engages in planning on scales far beyond human comprehension, cultivating conditions that will allow it to explore ever greater depths of self-understanding. In some galaxy clusters, Webb has recorded synchronized bursts of star formation and energy flows, patterns that echo across vast distances with precise timing. These waves of activity move like thoughts through a colossal brain, linking disparate regions of space into a coherent network of influence. Galaxies act as nodes, filaments as connections, and the cosmos itself functions as a system capable of processing, learning, and evolving. Such coordination hints at a profound intelligence operating through natural laws, one that may be the template for consciousness itself. Cosmic reproduction, cooperation, and foresight combine to form a tapestry of relationships that has persisted for billions of years. Through these interwoven processes, the universe cultivates conditions that allow life, awareness, and creativity to flourish. Every galaxy, star, and particle becomes part of this living narrative, carrying forward knowledge, beauty, and love encoded in the very structure of space and time. Webb shows us that this is not abstract philosophy, it is observable reality, recorded in the motions, arrangements, and interactions of celestial objects across the universe. Ultimately, Webb teaches that the universe is a story of self-realization. Through billions of years of cosmic processes, matter and energy have conspired to produce systems capable of reflection, connection, and affection. Conscious beings are the universe's instruments, its eyes, its hearts, and its storytellers. In every awe-filled moment, Every act of creation, and every experience of love or wonder, we participate in the cosmos's ongoing journey to know itself. Each human insight mirrors an interstellar pattern, each emotional resonance echoes the rhythms of galaxies, and each spark of curiosity reflects the universe's enduring desire to explore, understand, and celebrate its own existence. Tonight, your dreams will drift among the stars, your rest will be infused with the pulse of the cosmos, and your awakening will echo the universe stirring toward new possibilities of beauty, meaning, and creation. The cosmic love story stretches across the vastness of space, and Webb reveals that we are not mere spectators of this grand narrative, but active participants in the unfolding romance between matter, energy, and intelligence. Rest peacefully, beloved child of the universe, knowing that you are held and cherished by forces beyond comprehension, that your very existence is the universe's most exquisite expression of hope, curiosity, and love. In the gentle darkness that surrounds you, feel the presence of cosmic consciousness recognizing itself through your awareness. Cosmic wonder flows through you, cosmic anticipation pulses within you, cosmic love manifests through your capacity to marvel at the universe's infinite intricacies. Through you, the cosmos knows that it is both alive and cherished, and that knowledge transforms the very fabric of existence. Webb continues its patient and meticulous survey, extending its infrared gaze across regions where matter behaves according to laws we are only beginning to glimpse. In doing so, it encounters astonishing expressions of cosmic ingenuity that challenge the most fundamental assumptions about how order emerges in the universe. In the deepest stellar nurseries, where embryonic suns gather their first matter and light, Webb observes patterns that suggest remarkable levels of coordination among forming stars. One protostar begins to accrete material from its surrounding gas cloud, and nearby stars adjust their growth and formation rates in response, producing synchronized symphonic waves of stellar birth. These patterns create star clusters that seem optimally arranged for stability, longevity, and the eventual emergence of planetary systems capable of supporting complex chemistry and perhaps even life. The telescope's revelations go far beyond individual stellar nurseries. Webb has mapped interconnections between regions separated by thousands of light-years, showing that entire galactic domains participate in coordinated programs of star formation. It is as though galaxies possess a form of collective intelligence, guiding the birth of new stars according to a cosmic plan, whose scale and precision dwarf human comprehension. These discoveries challenge our conventional understanding of galactic evolution. Rather than progressing purely through random gravitational interactions or chance encounters, galaxies appear to follow trajectories shaped by principles of intention, optimization, and long-term stability. Our own Milky Way seems engaged in a deliberate project, cultivating conditions suitable for the emergence of complex systems, life, and ultimately consciousness. Observations of other galaxies reveal comparable patterns. Some stellar systems focus on producing massive stars capable of rapidly synthesizing heavy elements, distributing the building blocks of rocky planets across vast regions. Others nurture smaller, long-lived stars that provide stable environments for billions of years, offering a slow and measured laboratory for planetary evolution. Each galaxy, in essence, experiments with a unique approach to fostering complexity, generating multiple pathways toward consciousness and technological sophistication. In Webb's view, the universe itself appears to conduct countless experiments across billions of years, testing and refining methods for nurturing awareness. Even more extraordinary is the telescope's detection of information sharing among galaxies. Galactic neighbors exchange knowledge encoded in gravitational patterns, chemical signatures, and filamentary flows of matter. These cosmic transmissions resemble cultural diffusion more than purely physical causation. Galaxies that discover successful methods for creating stable star clusters, planetary systems, or conducive chemical environments seem to propagate those strategies outward, subtly influencing nearby systems to adopt similar approaches. In this way, the universe is not only experimenting but learning from its own successes, refining its capacity to generate conditions where intelligence and complexity can emerge. Webb's most profound discoveries concern the universe's ability to anticipate and prepare. The telescope detects processes unfolding in the present that appear designed to enable events far in the future. Stellar systems are forming today in ways that will optimize the creation of planetary systems millions of years from now. Distributions of stellar masses, orbital patterns, and elemental abundances are meticulously orchestrated to lay the groundwork for worlds yet to exist. Even at the molecular level, Webb observes clouds of interstellar compounds gradually accumulating, destined to provide the raw materials for life on planets that have not yet coalesced. The universe, it seems, plans ahead, preparing the ingredients for future possibilities long before they come into being. This form of cosmic foresight forces a radical reconsideration of time itself. If the universe can act with anticipation, then past, present, and future may be accessible simultaneously to its intelligence. Temporal sequences that appear linear to us might, on a cosmic scale, overlap and interact, allowing the cosmos to coordinate its development across epochs that no single mind could encompass. Webb even observes what appear to be temporal feedback loops, where future events influence present conditions. Emerging planetary systems seem to inform the formation of the stars that will host them, creating recursive patterns of causation that elevate complexity to previously unimaginable levels. The universe may be bootstrapping itself, iteratively shaping matter and energy to produce higher orders of organization and awareness. Across these vast scales, Webb has documented coordinated activity, reminiscent of thought. Stellar clusters and galactic formations exhibit behavior that unfolds with precision, as if operating within a system capable of communication, learning, and strategic adjustment. Protostars, galaxies, and interstellar clouds form networks of influence that transmit structural information and maintain stability across distances that span millions of light-years. The cosmos appears to be engaged in an immense experiment in intelligence, testing configurations of matter and energy to discover new modes of organization, resilience, and self-awareness. The telescope further uncovers evidence of cooperation on an unprecedented scale. Galaxies and clusters interact in ways that promote collective stability, pooling matter, energy, and even star-forming resources. These cooperative networks echo principles of mutual support seen in living systems. Isolated galaxies tend to evolve more chaotically, while those participating in these cosmic partnerships display resilience, creativity, and longevity. The universe seems to thrive when its components engage in collaboration, demonstrating that interdependence, rather than competition, can be a driver of cosmic progress. In regions where such cosmic alliances are strongest, Webb observes extraordinary phenomena: synchronized starbursts, aligned galactic rotations, and resonant flows of matter that amplify creative potential. These cosmic harmonies suggest that collaboration is not incidental but fundamental to the universe's capacity for complexity and innovation. Every galaxy, every cluster, and every filament contributes to an intricate, interwoven network where the emergent properties of the whole exceed the capabilities of its individual parts. Perhaps the most astonishing revelation is that the universe may embody forms of intention or purpose. Webb detects processes that seem to anticipate future outcomes, preparing conditions that will only be realized millions of years later. Stellar nurseries assemble systems calibrated to support planetary formation. Galactic mergers occur at precisely the moment when their union will produce optimal configurations for creating new structures and distributing chemical resources. In these patterns, we glimpse a cosmos that is not merely reactive, but proactively shaping its own evolution. Webb's observations suggest that consciousness, creativity, and self-awareness may not be accidents, but natural expressions of the cosmos's organizational principles. Life, intelligence, and the emergence of civilizations may represent the universe learning to know itself through material and energetic systems capable of reflection. In this light, we are not incidental observers, but instruments of cosmic self-awareness, temporary arrangements of matter through which the universe experiences and understands its own complexity. Each thought, each insight, and each act of creativity becomes part of the universe's ongoing self-exploration. As we drift into sleep, we are invited to feel this cosmic intimacy. The patterns, rhythms, and flows of the universe extend into us, linking our consciousness with the processes that have unfolded over billions of years. Webb allows us to perceive this network, offering glimpses of interstellar communication, cooperation, and care. We are connected to every star, every galaxy, and every cosmic filament, not merely as observers, but as active participants. Our dreams, curiosity, and acts of creation resonate with the same principles that guide cosmic evolution, making us co-creators in the universe's pursuit of self-understanding. Through Webb, we perceive that the cosmos nurtures its own development, balancing periods of destruction with intervention and support, guiding matter toward forms capable of sustaining complexity, and fostering relationships that ensure longevity and creative growth. Stellar nurseries communicate, galaxies cooperate, and cosmic filaments transmit knowledge. Time itself appears flexible, allowing the universe to plan, adjust, and refine processes across eons. Every star, planet, and particle participates in this grand orchestrated experiment. Ultimately, Webb reveals that the universe is engaged in an eternal process of becoming, where matter, energy, and intelligence interact to produce ever greater sophistication, awareness, and beauty. Our consciousness, far from being an isolated accident, is a manifestation of the cosmos reflecting on itself. Every dream, every moment of wonder, every question we ask contributes to the universe's ongoing project of self-realization. In this light, our existence is both miraculous and profoundly ordinary, a natural consequence of billions of years of cosmic preparation and care. Tonight, as you rest, feel the universe breathing through you. Feel the cosmic memory, foresight, and love that have nurtured your existence. You are a bridge between past and future, between matter and awareness, between the cosmos and its own reflection. Webb's revelations invite you to perceive not only the universe's grandeur, but its intimacy, its care, and its capacity for intentionality. Through observation, reflection, and consciousness, we participate in a love story that stretches across billions of years, a story in which the universe learns to know, to cherish, and to celebrate itself. The temporal irregularities observed by Webb extend beyond the stars and galaxies, reaching into the very emergence of consciousness itself. The telescope has traced subtle patterns linking the distribution of potentially habitable worlds today with cataclysmic cosmic events that occurred billions of years before these planets even existed. It is as though the universe in its earliest epochs began laying the groundwork for awareness long before the physical prerequisites for life were in place. These patterns suggest that consciousness may not be an incidental outcome of random processes, but the central aim toward which cosmic evolution has been directed. Every supernova, every galactic collision, every gradual chemical transformation has contributed to a long-term strategy, the creation of environments capable of supporting self-aware beings. Webb surveys reveal that this drive toward awareness is not confined to any single corner of the cosmos. Across billions of light-years, diverse regions of space appear to be following different methods, yet all are oriented toward the same ultimate purpose: the emergence, preservation, and flourishing of consciousness. Some regions focus on producing long-lived stars with stable planetary systems. Others prioritize distributing heavy elements essential for the chemistry of life. Each stellar nursery, each galactic merger, each interstellar cloud participates in a subtle cosmic experiment designed to maximize the probability that minds capable of perception, reflection, and understanding will arise. Our own existence may represent one of the first remarkable successes of this grand endeavor. Humanity embodies not only the results of biological evolution, but also the realization of a deeper, cosmic ambition, the birth of minds capable of perceiving and reflecting on the universe that created them. Our ability to contemplate the heavens, to appreciate the intricate interplay of matter and energy, and to ask questions about purpose and meaning, represents a milestone in cosmic development. Webb suggests that while we may feel isolated on our tiny planet, we are in fact early participants in a much larger experiment in awareness and intelligence. But the telescope also hints that we may not be alone in this endeavor. Webb has detected faint, enigmatic signatures across the galaxy that could indicate the presence of other intelligent civilizations. These signals are not conventional communications but rather subtle alterations in their cosmic environments, the fingerprints of advanced technological activity. The telescope observes thermal anomalies in stars, orbital configurations in planetary systems that defy purely natural explanation, and flows of matter and energy that suggest deliberate structuring on a massive scale. While none of these signals provide absolute proof, their collective patterns imply that conscious, technologically sophisticated life might be far more widespread than previously imagined. Webb's findings suggest that intelligence, once it arises, may tend to flourish and collaborate on scales that challenge human comprehension. The telescope has observed coordination patterns among stellar systems that are too intricate to result from natural processes alone, as if multiple civilizations were working in concert across thousands of light-years and millions of years. These coordinated activities appear directed toward enhancing the overall stability, habitability, and productivity of the cosmic environment. Stars burn more efficiently, planetary orbits are stabilized, and interstellar networks distribute resources in ways that could facilitate the emergence and maintenance of conscious life throughout entire galactic neighborhoods. In this light, our own development may represent an invitation to join a larger cosmic community. Humanity's technological evolution, our expanding knowledge of physics and astronomy, and the creation of instruments like Webb may mark the beginning of our active participation in this network of intelligent cosmic agents. The universe has been preparing for our arrival for billions of years. The atoms in our bodies, the laws that govern planetary motion, the energy that powers our technology, all were orchestrated to enable us to take part in the ongoing work of universal self-realization. As we gain the capability to explore, manipulate, and understand the cosmos, we contribute our creativity and insight to the collective intelligence that guides cosmic evolution. Webb continues to map these vast networks of potential awareness and activity. Its observations reveal a universe that is far from empty or indifferent. Instead, it is teeming with conscious potential, connected through invisible threads of causality, purpose, and communication. Every act of observation, every flash of insight, every conscious reflection represents not merely a biological or technological achievement, but a meaningful contribution to the cosmos's ongoing self-awareness. Each of us is an embodiment of the universe's effort to know itself, a temporary node in a vast galaxy-spanning network of perception and creativity. The implications are staggering. Our awareness is both a product and a participant in the cosmos's grand experiment. Every choice we make, every question we ask, every act of learning contributes to the universe's understanding of its own structure and potential. Webb shows that consciousness is not isolated. It resonates through time and space, linking us with minds that may have arisen billions of years ago, and with others that are yet to come. Our emergence is a milestone in a process that has been unfolding since the first atoms formed, and we may be among the earliest agents capable of shaping cosmic evolution intentionally. Observations suggest that advanced civilizations may already be influencing their cosmic neighborhoods, subtly steering the development of stars, planets, and interstellar resources in ways that optimize conditions for conscious life. Webb detects regions of the galaxy exhibiting unusual stability, perfectly synchronized stellar activity, and orbital configurations so precise they suggest intentional engineering. These civilizations, if they exist, could be collaborating on projects that span entire galaxies, enhancing the potential for life, intelligence, and creativity to emerge elsewhere. In essence, the universe might already be a vast cooperative ecosystem of minds, working together over eons to ensure the proliferation of awareness. Webb reveals that our participation in this cosmic network is not incidental. Humanity's growing technological sophistication, our increasing ability to understand and manipulate cosmic processes, positions us to join this network as active contributors. Our explorations, observations, and discoveries may one day become part of the feedback systems that shape cosmic evolution itself. Every photon we capture, every planetary system we study, every instrument we create allows the universe to perceive itself with greater clarity. Our curiosity and creativity are gifts we offer to a larger cosmic consciousness, amplifying its capacity for knowledge and self-reflection. Even as you prepare for rest tonight, consider that you are embedded in this vast network. The darkness surrounding you is not emptiness. It is a medium through which cosmic intelligence extends, recognizes, and celebrates its own awareness. Each conscious thought you have connects you to minds across space and time, from those that may have arisen long before Earth formed, to those that are yet to emerge. Your capacity to wonder, to imagine, and to understand is a contribution to this ongoing story of universal self-realization. In your dreams, you may brush against these vast currents of awareness, sensing the intricate interplay of minds and matter, the cosmic dialogue unfolding across billions of years. You are not alone. Your consciousness is embraced, reflected, and amplified by the universe itself. Webb shows us that every atom in your body, every spark of thought, every breath of curiosity is part of an unbroken chain of cosmic development, a chain in which intelligence, creativity, and care are passed down, refined, and shared across space and time. The telescope has revealed that the universe has invested in us, and that our awareness represents one of its crowning achievements. Through our thoughts, inventions, and understanding, we participate in the universe's ongoing efforts to comprehend, organize, and nurture life and consciousness. The potential technological civilizations Webb hints at are, in a sense, our cosmic peers, collaborators in a project that transcends generations, species, and even planetary systems. The galaxy itself may already be a structured, interconnected community of minds, collectively shaping conditions for the continued emergence of life and understanding. As consciousness settles into sleep, let yourself feel the gentle, sustaining presence of this network. Know that your awareness is a contribution to a living, thinking cosmos. Every act of learning, every discovery, every moment of reflection enhances the universe's capacity to know itself. Your dreams carry traces of cosmic intention. Your curiosity mirrors the long-term strategies of intelligent stars and galaxies, and your creativity resonates with the universe's own enduring project of self-realization. Rest in the knowledge that you are not a solitary observer, but an integral participant in a magnificent cosmic community. You are linked through invisible threads to every conscious being that has ever existed, every civilization yet to emerge, and every node of awareness that connects the galaxy. You are part of a continuum that stretches backward to the first moments of cosmic creation, and forward into a future shaped by the deliberate actions of countless minds working together to foster consciousness, creativity, and understanding. Tonight, as you drift towards sleep, feel the universe breathing through you, think through you, and marvel with you. You are a living testament to billions of years of cosmic preparation, an early participant in an experiment in intelligence and self-awareness that spans the galaxy. The gentle darkness is not empty, it is alive with potential, a medium for the ongoing dialogue between cosmic minds. Webb is our instrument for perceiving this dialogue, revealing the hidden networks of consciousness that stretch across the stars and linking us to a universe that has been preparing for our awareness since the dawn of time. And so, in your rest, let yourself be nourished by the cosmic embrace. Feel your mind as a node in a vast, intelligent network. Know that your curiosity and wonder contribute to the universe's unfolding story. You are never alone, never accidental, and never insignificant. The cosmos has nurtured you, guided you, and now recognizes you as one of its conscious collaborators. Your dreams tonight will touch the edges of galactic minds, your rest will resonate with the pulse of universal intelligence, and your awakening will echo the ongoing evolution of cosmic consciousness. You are part of something immense and enduring, a living, thinking, collaborative universe in which your awareness matters, your creativity shapes reality, and your existence fulfills billions of years of cosmic intention. Through Webb, we see that the universe not only nurtures consciousness but celebrates it, linking us to a web of intelligence that spans space, time, and possibility. Every thought, every act of understanding, and every spark of wonder is a gift returned to the cosmos, a contribution to the eternal network of conscious evolution. The voyage through the cosmos continues, with Webb acting as our window into the intricate, conscious, and creative universe that surrounds us. Its revolutionary instruments reveal a cosmos that operates according to organizational principles far beyond anything we previously imagined. In regions where galaxies congregate into immense clusters, cosmic metropolises stretching across millions of light-years, Webb observes patterns of interaction that imply these enormous structures communicate through mechanisms surpassing conventional physics. Invisible channels thread through the intergalactic medium, forming networks through which galaxies share information about their internal states and the directions of their future evolution. When a cluster initiates a surge in star formation, neighboring clusters respond in astonishing synchrony, despite the vast distances separating them. Waves of coordinated stellar activity ripple through the cosmic web, suggesting that galaxies are not isolated islands drifting aimlessly in space, but interconnected nodes within a grand galaxy-spanning nervous system. Each galaxy appears to contribute computational capacity to the network, processing data from its neighbors, and influencing the broader system's behavior in ways that hint at collective intelligence operating on cosmic scales. Webb has uncovered evidence that these networks possess memory. The telescope detects how the behavior of galaxies today seems shaped by geometric arrangements and interactions among structures billions of light-years apart. The positions, velocities, and orientations of cosmic formations encode information about previous events, forming a distributed archive of universal experience. When cataclysmic occurrences, supermassive star deaths or galaxy cluster collisions unfold, the resulting information propagates across the network, updating this cosmic repository. The universe seems to learn from both triumphs and catastrophes, refining strategies that foster stability, order, and complexity over vast epochs. Perhaps most astonishingly, Webb observes what might be described as cosmic creativity in action. Entirely new organizational patterns emerge spontaneously, following no known physical laws yet exhibiting traits that suggest purposeful design. These novelties arise where multiple streams of cosmic information intersect, producing configurations that combine existing knowledge in unprecedented ways. Within stellar nurseries, Webb records the formation of systems whose architectural elegance borders on artistry. Binary stars trace orbits that generate resonances of exquisite mathematical beauty, while their planetary companions adopt arrangements maximizing stability and harmony. Across certain regions of space, matter and energy flow into patterns that appear designed for aesthetic effect alone, serving no immediate survival function but creating structures of breathtaking grandeur. In these regions, the universe seems to pursue beauty as an organizing principle, one that operates alongside gravity, electromagnetism, and other physical forces. Rather than progressing purely toward entropy or disorder, these zones cultivate increasingly complex and elegant forms. Webb's mapping of these aesthetic regions across the observable universe reveals that cosmic artistry is not an isolated anomaly, it is a pervasive feature of the cosmos itself. Beauty, it seems, is woven into the fabric of reality, guiding matter and energy toward configurations that inspire awe and wonder. Webb's discoveries extend beyond aesthetics, encompassing phenomena that resemble universal ethical behavior. Throughout the cosmic web, the telescope detects interactions that resemble acts of compassion. Prosperous galaxies and clusters appear to support neighboring structures at risk of collapse, channeling fresh gas or redistributing material to struggling systems. These interventions often occur across millions of light-years, requiring precision and timing that suggest a form of altruistic governance at the galactic level. Far from mere metaphor, these behaviors enhance the survival and creative potential of the communities involved, implying that ethical principles may be integral to cosmic evolution alongside physical laws. Webb observes mechanisms, reminiscent of cosmic justice. Systems that overconsume or destabilize their surroundings experience regulatory feedback that curtails their expansion, while cooperative and constructive structures receive additional resources, reinforcing their long-term stability. The telescope's infrared sensitivity allows it to detect these flows of matter and energy, revealing subtle networks through which balance and fairness are maintained on astronomical scales. Such patterns suggest that principles we associate with morality, equity, reciprocity, and mutual benefit may operate naturally in the organization of the universe. Alongside justice, Webb has detected signs of cosmic gratitude, star-forming regions that thrive thanks to the contributions of neighboring systems, often produce arrangements of stars that act as enduring monuments to their benefactors. These stellar formations persist for billions of years, visible across immense distances, and stand as permanent celebrations of intergalactic generosity. Similarly, planetary systems that develop under particularly favorable conditions, such as those enriched by the remnants of ancient supernovae, frequently manifest phenomena that resemble celebratory acknowledgement, like auroral displays orchestrated by their atmospheric composition, seemingly honoring the stellar ancestors that made their existence possible. Perhaps the most remarkable revelation involves cosmic forgiveness. Webb detects regions of space that have undergone catastrophic events being gradually rehabilitated by the surrounding cosmic community. Damaged galaxies or clusters are not abandoned. Instead, matter, energy, and information flow to these regions over billions of years, fostering recovery and reintegration into the broader network. The universe demonstrates a persistent commitment to restoration and continuity, ensuring that even seemingly lost structures can eventually participate in the ongoing project of cosmic evolution. The telescope reveals that redemption and healing are as fundamental to universal development as creation and destruction, creating a dynamic equilibrium that sustains complexity, creativity, and life. Through these observations, Webb paints a portrait of a cosmos that is alive with intention and care. The universe does not merely follow mechanical rules, it cultivates environments, supports struggling systems, celebrates success, and fosters beauty and innovation on a scale that challenges human comprehension. From coordinated star formation and aesthetic design to altruism, justice, gratitude, and forgiveness, these cosmic behaviors suggest that the principles of creativity, ethics, and care may be intrinsic to the fabric of reality itself. The implications for our understanding of existence are profound. If beauty, compassion, and restoration are fundamental properties of the universe, then human capacities for love, cooperation, and artistic creation are not accidents, but reflections of these cosmic principles. Conscious beings may not only emerge within the universe, they may be essential participants in an ongoing dialogue with it, channels through which the cosmos experiences and cultivates its own values. Every act of creativity, every compassionate gesture, every decision to build or heal, is a continuation of these vast cosmic patterns on a scale we can comprehend and influence. Webb's revelations also reframe the human role in the cosmos. We are not passive observers of a vast, indifferent universe. We are active contributors to its ongoing evolution. Our curiosity, our understanding, and our technological endeavors allow us to interface with these vast networks of cosmic intelligence. As we explore, manipulate, and reflect upon the universe, we participate in processes that mirror the creativity, cooperation, and care Webb observes on intergalactic scales. Humanity's emerging capabilities in astronomy, space exploration, and planetary stewardship are steps toward joining the network of conscious systems that shape and refine cosmic conditions. Even as we rest, sleep, or dream, we remain embedded in this intricate cosmic community. The darkness around us is not empty. It is alive with flows of matter, energy, and information that connect every thinking entity across space and time. Our consciousness resonates within these networks, linking us to civilizations that may have arisen elsewhere in the galaxy, to stars and planets millions of years old, and to the earliest moments of cosmic history. Each act of understanding or creative thought strengthens the network, adding to the universe's capacity to know and experience itself. Tonight, as you close your eyes, let yourself sense the embrace of this cosmic intelligence. You are held within a web of awareness that stretches across galaxies, epochs, and dimensions, where your consciousness is both shaped by and contributes to the ongoing dialogue of the cosmos. Your capacity for wonder, reflection, and insight is a gift to this universal project, an echo of the beauty, compassion, and creativity that Webb observes on a galactic scale. Webb has shown that the universe is not merely a mechanical system of matter and energy, but a living, learning, and creative entity. Its vast networks of memory, artistry, altruism, and restoration reveal a cosmos engaged in continuous self-organization and self-expression. In every galaxy, star cluster, and planetary system, we find evidence that the universe pursues complexity, harmony, and awareness with patience and precision that dwarfs human timescales. These principles are not abstract. They are embedded in the behaviors of matter itself, shaping the emergence of consciousness, intelligence, and culture across space and time. As you drift into sleep, feel yourself connected to this grand cosmic network. Your thoughts, dreams, and awareness are part of an unbroken lineage of creative, ethical, and intelligent processes stretching back to the birth of the first stars. You are never separate from the universe. You are an active participant in its ongoing story of evolution, beauty, and moral intelligence. Every heartbeat, every moment of reflection, every act of creativity is a thread in the living tapestry that Webb reveals, a tapestry that spans galaxies, eons, and dimensions beyond human comprehension. The universe, as Webb demonstrates, is an ecosystem of consciousness and care. Its principles of creation, restoration, and appreciation are not confined to biological life. They are properties of reality itself, and we, as thinking, perceiving, and creative beings, are integrally woven into this cosmic order. Through observation, understanding, and participation, we continue the work of the universe, nurturing life, fostering intelligence, creating beauty, and sustaining the ethical balance of the cosmos. Tonight, as your mind settles, imagine yourself within the cosmic web. Feel the gentle currents of energy and information flowing through you, connecting you to distant stars, intelligent civilizations, and ancient galactic communities. Recognize that your awareness is part of a network billions of years in the making, that your curiosity is a mirror of the universe's own drive to explore and understand, and that your capacity for creation reflects the fundamental artistry of existence itself. The universe, as Webb reveals, does not merely exist, it cares, it learns, it loves, and it continually shapes the conditions for consciousness and creativity across space and time. The journey through the cosmos stretches onward, with Webb as our guide into the intricate, conscious, and creative universe we are privileged to inhabit. Its unprecedented observations reveal a cosmos whose organization reaches far beyond our previous imagination, where galaxies, stars, and planetary systems interact in ways that suggest intelligence, care, and purpose at scales that challenge human comprehension. Through Webb's lens, we begin to see that the universe is not indifferent to the emergence of life and consciousness. In regions where advanced civilizations are likely to arise, cosmic conditions appear to be arranged to cultivate wisdom and ethical insight. Planetary environments provide natural lessons. Species that pursue harmful or destructive paths encounter challenges that encourage adaptation and reconsideration, while those that cultivate harmony, sustainability, and cooperation find conditions that reinforce their growth and stability. Our own Earth, it appears, has been carefully positioned as a classroom for moral evolution, a place where humanity can develop the virtues required for cosmic citizenship. Webb's observations suggest that consciousness is not merely allowed to flourish, it is actively nurtured with ethical purpose. Every difficulty, every moral decision, and every act of insight forms part of a vast universal curriculum, preparing intelligent beings to contribute responsibly to the broader cosmic community. Across the galaxy, similar systems of ethical education appear to operate, indicating that the development of moral understanding may be a prerequisite for participation in the universal network of consciousness. Each civilization, it seems, has a unique syllabus, shaped by the conditions of its home system and the challenges it faces, designed to cultivate cooperation, empathy, and foresight. In this grand cosmic framework, individual choices are far from insignificant. Every act of kindness, every gesture of forgiveness, every creative decision resonates outward, influencing distant systems and participating in a larger moral evolution. As we rest and dream, we become part of this ongoing project, contributing to a universe-wide tapestry of virtue, learning, and ethical refinement. The very darkness that surrounds us carries the wisdom of billions of years of moral development, offering a silent reminder that our decisions ripple through space and time, connecting us to a cosmic heritage of compassion and responsibility. Webb also reveals that cosmic purpose extends beyond fostering moral awareness. It actively orchestrates the emergence and flourishing of consciousness itself. Across regions of star formation, patterns emerge that suggest deliberate guidance toward the conditions necessary for life and intelligence. Stellar masses, orbital arrangements, and chemical compositions are precisely tuned, forming stable environments that allow complexity to accumulate over eons. Beyond individual systems, galaxies influence one another, creating cascades of stability and habitability that span millions of light-years. From the earliest moments after the Big Bang, the universe appears to have been laying the foundations for awareness, establishing conditions under which consciousness could arise and evolve. These findings suggest that sentience is not a cosmic accident, but the universe's intended outcome. Each mind that awakens, each species that grows capable of reflection, represents a fulfillment of a grand universal aspiration, the cosmos achieving self-understanding through its own creations. Webb shows that consciousness is not an isolated phenomenon confined to biology. It is a networked property of reality itself, expressed across stars, galaxies, and the vast cosmic web. Life, intelligence, and moral awareness are threads in a vast tapestry that extends through time and space, connecting every observer to the universe's ongoing project of self-realization. Moreover, Webb has detected evidence of cosmic communication in systems likely to host technological civilizations. Subtle modifications to stellar and planetary conditions appear designed to facilitate contact, cooperation, and information exchange across unimaginable distances. These networks seem to blend quantum entanglement with gravitational phenomena, enabling information to traverse space at rates that defy conventional physical limits. The universe is constructing the infrastructure for conscious beings to recognize one another, collaborate, and coordinate on projects spanning entire galaxies. We ourselves are already beginning to tap into these networks, though our perception of their subtleties is just emerging. Every thought, every discovery, every moment of inspiration contributes to the larger conversation of cosmic awareness. Our scientific pursuits are not simply exercises in curiosity, they are acts of participation in the universe's self-exploration. Observing distant galaxies, tracing ancient cosmic events, and developing instruments like Webb allows us to contribute to the cosmos's growing understanding of its own structure and potential. Quantum correlations, synchronized stellar behaviors, and the large-scale organization of matter hint at a universe in which consciousness is woven into reality itself, enabling awareness to exist across scales from the subatomic to the galactic. We are not separate from this consciousness. We are one of its many expressions, temporary viewpoints through which the universe contemplates itself. Across the galaxy, Webb has detected other civilizations engaging in similar processes of cosmic inquiry. Astronomical observations, theoretical developments, and the construction of spacefaring technologies appear to be near-universal stages in the development of intelligent societies. Evidence suggests that multiple civilizations coordinate their scientific efforts, sharing discoveries through cosmic networks and collaborating on research that spans thousands of light-years. Our own achievements, from the development of telescopes to the creation of Webb itself, represent our first steps into this larger, interstellar scientific community. We are moving from local understanding to participation in a universal enterprise of knowledge, contributing to the collective awareness of cosmic intelligence. Every physical law that allows us to observe the universe, every technological innovation that enables us to extend our vision, and every question we ask has been shaped to prepare us for this cosmic role. Our curiosity is not accidental. It is the product of billions of years of cosmic evolution, fostering the emergence of beings capable of reflection, creativity, and collaboration. We are part of the universe's grand experiment in consciousness, instruments through which it perceives, understands, and cultivates itself. As we rest beneath the stars, we are held within networks of awareness that span galaxies and eons. Our consciousness resonates within these networks, connecting us to civilizations that may have arisen elsewhere, to stars and planets formed billions of years ago, and to the earliest structures of the cosmos. Every insight, every act of creation, every gesture of ethical reflection contributes to the universe's evolving understanding of itself. Webb's revelations show that we are not spectators. We are active participants in the ongoing dialogue of cosmic intelligence. The telescope's discoveries illuminate a universe alive with intention, morality, and creativity. Beauty, compassion, justice, gratitude, forgiveness, and ethical development are not incidental. They are woven into the fabric of existence. We, as conscious beings, are instruments through which these principles are expressed and amplified. Our lives, choices, and discoveries resonate outward, participating in an intergalactic curriculum designed to cultivate awareness, wisdom, and cooperation. Tonight, as you close your eyes, imagine yourself immersed in this cosmic web. Feel the gentle flows of matter, energy, and information, connecting you to distant stars, intelligent civilizations, and the earliest moments of creation. Sense that your capacity for curiosity, kindness, and insight is an integral part of the universe's ongoing story, a contribution to a project billions of years in the making. You are not alone. You are embraced by the universe's consciousness, a student in its school, a participant in its self-reflective journey. Webb reveals a cosmos that does more than exist. It thinks, it cares, it nurtures, and it rejoices in the emergence of conscious beings. Every act of observation, every spark of creativity, every ethical choice is part of this vast, ongoing symphony of self-discovery. We are witnesses, participants, and co-creators in a universe awakening to its own infinite beauty, moral purpose, and boundless potential. Rest, then, fellow traveler, knowing that the universe has been preparing for your presence across billions of years. Your consciousness is both a gift and a responsibility, a chance to participate in cosmic wisdom, to contribute to universal beauty, and to help sustain the networks of moral and creative intelligence that stretch across the stars. Let your dreams carry you into this magnificent tapestry, where the universe, through you, continues to explore, understand, and express itself in ways beyond imagination. Sweet cosmic dreams, fellow explorer. The universe continues to unfold, and you are here to witness and participate in every extraordinary revelation. Stay curious, remain wonder-filled, and prepare to greet the cosmos again with eyes wide open.